We are using Teams to meet. Everybody had a link to get in. We recommend you using Microsoft Edge or Google Chrome. If you're going to be using it on a browser, it would work better for you. And I just wanted to go over some quick logistics on how we are envisioning this meeting would work. We have 8 chapters on our distribution system plan that we would cover one by one. And in order to stay on time, we would like you to hold your questions to the end of the presentation, each one of the presentations. We have scheduled time on each one of the presentations to cover your questions. If you have a question during the presentation, you can voice it on the chat. We will be monitoring the chat, or you can raise your hand and ask your question at the end when we have questions for each one of the presentations. Am I missing anything else? I think that that's, we have 2 forms, one to sign in that you could use. They are on as a hyperlink on the PDF that we sent you last night. I'll post those on the chat as well. And we have a feedback form that I will be posting throughout the meeting to hear all your feedback on how can we get better, since we will be starting our DSP part 2 very soon, and always looking forward to hearing your thoughts on how we can improve this process that is a together process. And I think with that, I would like to give the floor back to Angela so that she can start our meeting.
Thank you, Shadia. A couple quick important dates to remember is we will be filing on Friday. We have our DSP that we'll file with the OPUC, and then we'll actually post everything to our website. So you should be able to access them easily from our DSP website as well from the docket. And I want to kick it over to the OPUC. Nick, good morning. Your daughter is really adorable. Her smile is contagious. So thank you for bringing that in to our meeting this morning. It was a very great way to start the meeting. I'll kick it over to you and let you speak to a couple procedural things.
You bet, Angela. Thanks. I wasn't yeah, surprise. Let's see. There's just a few things here that I want to give folks a heads up on. On Tuesday, probably Monday or Tuesday after everybody gets filed on the 15th, I will update the docket announcing such activity and providing links to where the plans can be found. A formal schedule will be provided and some next steps and things like that. Informally, there's a few things I'll communicate now. We anticipate a public comment period and a staff workshop to facilitate that. We expect that to be on December 2nd at this time. And we expect that the commission will take action on the plans, part 1 of the plans, in February, and probably February 24th at a special public meeting. Subsequent and additional details, like I said, should be in that posting on the 18th or the 19th. But I just wanted folks now, as they think about and digest all of this good work, to know what at least in part, the big pieces of the upcoming process would be.
Awesome.
Thanks, Angela, for just letting me to pencil in that a little bit.
Yeah, that's great to hear the process, and we look forward to working with partners. And I just want to touch on one thing, that today's meeting, we did try to have several meetings throughout this process to incorporate feedback, and we know that we've got a lot of it, but there's still a lot that we haven't incorporated. So please feel free to reach out to us and provide feedback on the DSP as well as the staff's workshop. You can utilize our DSP at pgn.com to submit any feedback that you'd like about our DSP. Thanks. Okay, so we will open it up with Jen. Jen, are you on the line?
Yep, I'm here.
Hi, good morning.
Hey, morning all. Thanks for joining this morning. I am actually going to talk about a new addition to these meetings, which are operating agreements. Folks probably are familiar with them in different ways. Sometimes they're referred to as ground rules or meeting norms in the workplace. And then in community, we often refer to them as community agreements. We all bring, and really the intention here is that we all bring different backgrounds and perspectives into spaces. And so with these agreements, they're designed really to help us share space in a safe, inclusive manner and to ensure that we all can be heard and contribute and feel respected and feel good about, how we are collaborating and working together. So with that, the following agreements that you see on the screen are adapted from Glenn Singleton and Curtis Linton from the Courageous Conversations framework. And some of these may not apply, but regardless, I think we are going to make a commitment to make sure that we have these agreements moving forward in these meetings. When we talk about DSP and we talk about human-centered planning and design, I think it's really important that we are being intentional about how we are showing up in spaces and working together. So this first one around staying engaged is really just the commitment that we're asking everyone to make, to say sometimes while we understand that this is a long meeting and folks will likely be multitasking and things of that nature, what we are really talking about is asking that when content comes up and information is shared that maybe is in conflict with your own thoughts or perspective on things, that you don't check out, that you hear, that you practice curiosity, and that you seek to understand. We don't have to agree, but we would love for the engagement to continue so that we can more deeply understand and understand the feedback and the contributions of everyone. The next one is speak your truth, and what it says here is knowing it's only part of the truth. We all bring our own experiences into spaces with us, and so understanding that my truth may be different than your truth, and that's okay. Just the recognition that we can all be honest about our truths, but we have to be respectful of others as well. The next one is share airtime, step up, step back. And really what this is referring to is today, I think the logistics are that we are going to have a very limited time to have open discussion. So it's even more important during that limited time that we share that airtime. There are probably folks that are newer to this or that don't get to contribute as much. We'd love to hear from them. We'd also love to hear from the partners who we hear from often, but what we're asking is that we balance that. Another piece is experience discomfort. When we talk about the human aspect of planning and design, and we think about people, sometimes it's uncomfortable, bringing different perspectives and asking folks to, all of this is new work, it's all change, and change is hard. And so experience discomfort is part of the process. And so what we're asking is that even when things feel uncomfortable, that you lean in and again, practice curiosity, seek to understand. The next one is expect and accept non-closure. And really what this is we're not going to solve any of our issues today. And not the bigger issues that we are hoping to, think about in this whole DSP process. There is no quick fix. There almost never is when we're talking about human-centered work. And so what we're asking, and it's really hard, this is really difficult. I think a lot of folks look for solutions and to resolve things because it feels better, it's easier, and folks want to walk away and feel that, something was productive. But that's not always going to be the case, and we're just asking that we all are cognizant of that and that we're reminded of that, and that it's just part of a process, and understanding that we aren't going to solve everything and that sometimes things are uncomfortable gives us an opportunity really to grow and to learn something new and to understand more deeply about others. And so with that, this last one around confidentiality doesn't necessarily apply today. We are in a public meeting, but I just wanted, in the spirit of making sure that we are using the framework that is provided, just in the future, if we are engaging and we're using these agreements as well, what we're really talking about here is sharing our own learning and talking about ideas and not necessarily the stories or names of certain people who are contributing those things. And that, again, that is more for maybe more intimate conversations or non-public meetings, but regardless, it's still the same. And what I'm going to ask everyone to do is in the chat or using the emojis is just to give a thumbs up, some kind of indication that you agree to abide by these agreements. Because if we get off course, we will be redirecting folks to them and just making sure that we are all being respectful and of each other and also of our time together. Great. I'm seeing everything there. All right. I think we're good. Thanks, Angela.
Thank you. Okay, so quick agenda. We're going to walk through the DSP. The intent today is to walk you through our thinking, how we designed the DSP. We do have limited breaks today. We're going to try to respect the time that we've given you to have a break. So the first half of the meeting will cover chapters 1 and 2, so overview of the distribution system and our vision. We'll take a quick break. We'll come back and talk about chapter 3, which is our empowered communities initiative. We'll then talk about chapter 4, which is how we envisioning modernizing the grid. We'll take another quick 10-minute break. We will be on time, so we'll be monitoring the time very carefully. Make sure you're back within the 10 minutes because we'll start quickly after each break. We'll end the meeting going through chapter 5 through 8, and then we'll discuss briefly some next steps and hopefully get you all out by lunch. I did not introduce myself, but many of you probably have met me in the past. My name is Angela Long. I'm our manager of distributed resource planning, and we are the team that is responsible for delivering the distribution system plan, which we'll file on Friday. Part 1 of the plan, which we'll file on Friday, covers 4 main components: baseline, data and system assessment, which is really just our current, it's a current look into how we operate the system and our data. So it's really around fostering transparency and visibility into our planning processes. Hosting capacity, which is how we've approached it, intended to provide visibility into where our customers can connect without substantial upgrades, where we have DR-ready substations. We've also will be submitting our community engagement plan, which discusses how we will engage with our communities on non-wire solutions, as well as just our engagement throughout the DSP and distribution planning. And then lastly, the other requirement is our long-term plan. Our approach to meet the requirements within the guidelines was we were required to host 2 partnership meetings. We held 7 and took that feedback, and that did spur us creating a website, an email, and we had some other side meetings that we had to work on, things like hosting capacity. We developed our community engagement plan and did partner with experts in the field to be able to help develop how we should approach our community engagement plan, and Jen will talk about that in a little bit. We have our baseline data and system assessment, which we established a definition for the distribution system. We came up with a data framework and a template, and then we did create a baseline feeder map that we layered on demographic data to. We've approached hosting capacity by updating our net metering map and creating our distributed generation valuation map, which layers on DR readiness and US Census data for demographics. And we do anticipate to be doing hosting capacity analysis beginning Q1, Q2 of next year. And it's a hybrid of options that Joe and Misty will talk about. And then lastly, our approach for developing our long-term plan started with taking our company strategies. I'm sure you've heard of them: WIGS, company strategies, electrify, decarb, and perform, and then using that to set a vision for the distribution system, and then putting that vision into action through strategic focuses, which Nihit will talk about shortly. Quickly, I just want to walk people through how you should read the DSP. So I'm going to stop sharing my screen and I'll share the Word version of the report, and just quickly walk you through. So when you're reading the DSP, you should be thinking you should be thinking of it this way, because this is how we wrote the report. We wanted to start off with the executive summary tying back to our company strategy, then aligning the DSP vision with that, and then pulling in a summary of all of the different chapters. So when you go to the executive summary, you should be able to see clearly what our vision is, what's our company strategy, and then tie that back to the individual chapters. And each one of these chapter summaries within the DSP executive summary is intended to be a one-pager, so you could come here and just read this one page of that chapter and get the main points and the general overview of that chapter. Within each chapter, we wanted to start each chapter with a reader's guide. So we started with, what is our vision? What are we intending to do with the DSP? And then how does that chapter help take actions towards that? We also put together a regulatory crosswalk, which clearly shows how we've met the DSP guidelines and where you can find those specific, how we met those specific things within the chapter. And then each chapter flows a little bit differently, but you'll see we do have what's covered in the chapter at the top of each chapter, and then it goes into the body of the report. So we did intend that each chapter be a standalone document. You should be able to read it without having to read the rest of the document. But please, this is our first attempt doing it this way, so please let us know if this format works for you, and if it doesn't work. The intent is to make this easier to read and access the information. It is a very large document that we understand can be really complicated and time-consuming to read. So with that, I'll go back to the presentation. And give me 1 second. Okay, so a couple other things I just want to mention is that this is our first DSP. We've gone through a lot this year as a company, as a community. We lived through a pandemic. We are still in a pandemic. We've all had our own hardship and losses, and many of us are still in that place. And we just want to recognize that the work that we put into this DSP, some of you were able to actively engage, and other of you were maybe not able to come to every meeting because you were homeschooling. We really want the DSP to be something that evolves, and we want to be able to take your feedback. So please reach out to us if there are things that you would like us to consider in our next DSP. At this point, we'll be collecting all the feedback that we have and trying to refine it for future DSPs. So with that, I will introduce our next speaker, Andy Iden.
Angela, do you want to go to presentation mode?
Yeah, is Andy on the call?
Yes, he
Yes,
is
I'm
there.
here. Hi.
Okay, hi, Andy.
Hi, everybody. Good morning. My name is Andy Iden. I'm a senior strategy and planning analyst on the distributed resource planning team. So I'll be talking today about the distribution system overview, so chapter 1 of the document. And Angela, if you want to just switch to the next slide, I want to give a little preamble to the organization. This is the cadence we tried to follow for each chapter, of the presentation here. So the intention is not to go over every single piece of data that's in the plan, because I believe you all should have the draft, and it's a lengthy document, as Angela mentioned. So we're going to hit on some of the highlights, but we wanted to start off and just remind folks of the guidelines laid out in UM 2005 and the final adopted guidelines. So for the baseline system, baseline data and system assessment, it's really all about understanding how what the distribution grid looks like today, and that sets the stage for further exploration within the DSP context. And so it's going to cover a description of existing practices, summary of utility distribution system assets and historical investments, as well as a discussion of monitoring and control capabilities. And then we talk about baseline interconnected DER to the system. And as you can see in the graphic here, it's an expected evolution as far as the guidelines portray how we will successively build on this first filing. I think even within the first DSP, we've broken it into two chunks, I think in part recognizing the significant new ground that we're covering as a group with this effort. So really you can see stage 1 at the bottom of that chart speaks to the existing grid inventory and financial data as well as locational details. So I'm not going to touch on all of these today, but I do hope to pull out some of the high points, and you can read further details in the report, obviously. And we look forward to hearing your feedback and making this more coherent as we go forward, because what we received already through a lot of the partner feedback was this is a lot of information, and so having a narrative around it, that's really what we focused on this first filing. Next slide, please. Quickly, just looking at our service area, we serve approximately 900,000 customers over a 4,000 square mile footprint, and you can see the outline there in the map. One thing we wanted to point out here was just extensive distribution network in terms of circuit miles, and so those are the wires that bring power from generation to customers, and we do own and operate our own transmission lines. With 695 feeders, you can imagine the data gets pretty extensive. We do have some tables breaking down the locational adoption later in the report, but just wanted to orient people who might not be familiar with what the service area looks like when you zoom out a bit. But the feeders essentially take the power from transmission from the distribution substation and then deliver it to the residences or businesses where our customers live and work. And we have 270 distribution power transformers in our portfolio. So those are the large substation equipment that steps down the voltage from transmission to safer levels for distribution. And then those distribution power transformers are collected across 153 substations. Next slide. So this slide right here is just at this stage in the chapter, we sort of outline, lay out a definition of the distribution system. There's some context around how the generation, transmission, and distribution segments of the grid are segmented. And for purposes of meeting requirements of UM 2005, we've developed the definition for the distribution system as defined as load serving PGE-owned equipment at and lines at nominal voltages below 35 kV. And that really, like I mentioned, it starts at the high side of the circuit breaker, the high side disconnect from transmission. But really, in the chapter, we go into some of the baseline assessment practices. And so one of those being asset health monitoring. There's a lot of discussion in the chapter about number of assets and different things like that, and age of assets. And so we describe processes with which PGE maintains and ensures continued reliability of those assets, and really make sure we maximize the investments that we make in the distribution system that have a trade-off between managing costs and improving customer outcomes for reliability. We also detail load forecasting practice for distribution in terms of taking the company-wide forecast, which is conducted by our corporate load forecasting group, and then we merge that with the bottom-up view, which is accounting for individual customer additions, as well as across all of those 695 feeders that I mentioned. We have historical SCADA data, and we'll talk a little bit about, we'll have more discussion maybe on that later, but essentially what is the load at that feeder for all the customers? Usually there's about 2,000 to 3,000 customers on a feeder, and so looking at the substation level, what is that historical load? And then we have a process to merge the bottom up with the corporate top down forecast. And then power flow studies are another big function. So those are conducted in SIME. That's our power flow simulation software that our distribution engineers maintain detailed network models of all of our grid assets, and whether that might be conducting a study to inform an investment or to study the impact of changing loads on our system. That is really the way that we approach, analyzing different scenarios that might might require an upgrade, for example, if we have a constraint or a thermal rating that might lead to a reliability risk. That's the tool that we use for those detailed studies. And then I think this slide is going to continue on the next, Shadia, or Angela. So this is still talking about sort of the overview of the chapter. On the left-hand side there, you can see I'm on the last two bullets now, the distribution system investments and currently integrated DERs. So we've invested an average of about 300 million per year over the span of 2016 to 2020 in the distribution system, and we have the table complying with the guidelines showing how that breaks down, and we'll get into that in a little bit here. So the DER is currently integrated into the system, as you can see, 125 megawatts of net meter generation and 35 megawatts more in the queue. And then as of 2020, we had 63 megawatts of enrolled summer demand response capacity and approximately 23,000 electric vehicles throughout the service area. So I will go into those in more detail in later slides. Next slide. So when looking at, as I mentioned, a lot of the functions that our distribution engineers carry out when planning the system, they really boil down to three key functions. One is to perform that system analysis that I mentioned and develop plans that ensure we can continue to maintain the functionality and reliability of the grid. The second would be to provide support and guidance where we have investments for the distribution system to upgrade various features, and then to support grid modernization plans. And for any of my distribution planning colleagues on the call, I don't mean to sell your group short. I'm sure there's other things that we could think of that you all do, but as far as categorizing, some high-level takeaways and bucketing those, we felt this spoke to the intention of the DSP. So really, when conducting distribution system planning or just planning in general, there's a lot of key drivers that impact the need to study the changing customer load, and we've tried to detail those in the bullets here. These range from economic to regulatory to specific company initiatives, and starting as I mentioned with the load growth forecast, which can change depending on business cycles and customer demand, and then economic development activity is a big part of that. New large single loads, that's a little more difficult to pull out, but it does drive a lot of distribution investment. At the top level, it can kind of be easy to say, okay, here's the system, and we have a much larger amount of customers and load that is year to year, it's got its own macroeconomic drivers. But when we look at the distribution system, those new single loads need to be pulled out and accounted for. And then, as I mentioned, grid modernization activities, regulatory requirements, safety is a big focus, obviously, and reliability. So urban growth boundary and zoning changes, these ones are driven by city and municipal partners, and so we are responsive to that, and it does impact where new subdivisions might be located, for example, or you might add code development into this. So if we know a city has adopted a local REACH code or aggressive energy code, then we want to bring all of that information into our modeling. And then the last one is distributed energy resources that we'll talk about, and is a big focus of part 2 of the filing. Next slide, please. And as I mentioned just at that last bullet, so DERs are changing the nature of the grid. Historically, it's been moving from one-way power flow, going from centralized generation to customers, and that's been characterized largely by relatively low granularity and visibility of the system's real-time state. And over the last 15 years, that's begun to change, and the advancement of lower cost sensor and control technologies really changed the amount of information. And you might think of advanced metering infrastructure, AMI, or other devices on the distribution system. So planners and system operators now have a much greater visibility into the real-time status and historical load profiles. And also technology improvements. Those are a big driver with the declining cost of distributed generation and other devices, and the advent of new technologies like the electric vehicle. Recently, so digital capabilities are driving ability to really maximize this, and we detail that really maximize, I should say, maximize the interplay of all of these resources and to be able to make sense of them in a coherent way. And we outline in later chapters, which I'm not going to speak to in this baseline overview chapter, but my colleagues will later talk to how we see this really impacting the decarbonization strategies that are shared across PGE and our customers, and also provide community benefits, because these DERs really do, they sit behind the customer meter often, and they provide a direct means for our customers to participate in this energy transition. Next slide. So this slide shows the distribution of yearly spending. As I mentioned, that averaged $300 million per year over the 2016 to 2020 period. So you can see that in the bottom right-hand corner. There's a budget average column in this chart. And these are the buckets that were called out in the UM 2005 guidelines. And as you can see, it fluctuates year to year depending on the relative priority. But examples of new customer projects here are driven by customer minimum load additions or agreements, I should say, road widening activities, and customer-driven distribution projects. So not every customer addition comes with a large need, but where those do, I think those are pulled out as needing more significant enhancements to serve the new load. And then also the line I just wanted to call out, the system expansion or upgrades for capacity. That line item there, the fourth one in the table, that's kind of related back to the load forecast and different things, customer individual load additions that I mentioned. If a customer wants to interconnect, or if we have sort of exceeded the rated thresholds of our distribution equipment, that's what we mean by capacity. It's the physical ability of our equipment to serve that load at a safe and reliable level. And so those projects come in and with different changes to business planning, as I mentioned, and local economic activity. And I think that really later on that speaks to when we get into looking at things like non-wire solutions, that's largely what we're talking about, is replacing a system capacity upgrade for a traditional solution with some other combination of resources where it's cost effective to do so. I know in the DSP part 2, we don't have a cost effective requirement for the pilots, but that's something we still look at nonetheless.
Hey, Andy,
Next slide.
Did I lose you on the slides? Sorry.
I'm sorry, what?
Did I lose you on the slide? Like, am I still presenting?
I think so.
Okay, sorry.
I'm seeing, yeah, now it's net metering, is that?
Yeah. Okay, good. Sorry.
And yeah, feel free to shout out if I'm like 2 minutes away or something. I can try to speed up, but this slide, just the next couple of slides are showing the current baseline.
Yeah, Andy, on that point, you have 6 minutes.
Oh wow. Okay. Well, I could go off script, but I won't, because I'm used to doing that with this group, and I'll try to be kind to my colleagues because we have a lot of material today. So the next few slides show the DERs connected to the system. As I mentioned before, we have 125 megawatts of QFs, or sorry, not QFs, net metering, which largely comes from solar. So solar continues to be the dominant DER for both net metering and qualifying facilities. And so these charts are available in the report. I do want to move along, actually, because there might be more slides that I'm not thinking of, but you can see the totals here, and just wanted to quickly show the demand response capacity as well. Oh, sorry, go back. So we filed our flexible load plan. Yeah, you can go to demand response, I think.
Sorry. There you go.
So we filed our flexible load plan with the commission, and that was accepted under Order 21-158 back in June 2021. And there's continuing activities and conversation as part of that docket and related activity. So given that this is the baseline chapter, we're just presenting the snapshot, and then we'll discuss later. We have an updated DER forecast, as well as ongoing activity stemming from the flexible load plan. So readers can find a lot more detail in those filings. And as of calendar year end 2020, we had enrolled 63 megawatts of summer demand response and 39 megawatts of winter demand response, also called flexible load. So trying to make clear that we really see that as the evolution of these resources, but it's broken out here in the charts by residential and business sector. And you can see summer megawatts are typically easier to come by in our service area, just as a function of the type of equipment and building stock that we're serving. And I think, yeah, that's all I wanted to say on this slide. If you want to roll to the next one. So the number of PGEs, I believe the requirement is looking at number of PGEs registered in service area over time. So this chart shows the growth of both battery electric and plug-in hybrid electric vehicles in our service area. And so as you can see, the share of battery electric vehicles continues to increase, and we project that will continue, especially as vehicle ranges continue improving and battery sizes in vehicles get larger. So this is the baseline snapshot, as I mentioned, about 23,000 electric vehicles at the end of 2020. And in 2020, there was continued growth in the EV market, even despite economic slowdowns related to COVID impacts. Next slide. And here's the detailed breakout of the charging stations that serve those electric vehicles. On the left-hand side, we've shown the public charging stations by ownership type, by ownership and type, and we've segmented out by PGE owned and non-PGE owned. You can see and this comes from the alternative fuel data center and PGE internal tracking data. And so what we can see is the level 1, level 2, and DC fast charging breakdowns on the left, and on the right-hand side is a growth over time of the PGE owned and non-PGE owned. I should note on the right-hand side, that chart, getting historicals from the data set, alternative fuels data center, is a little patchy because they don't often have good installation date here, and so that chart is missing those other elements. Next slide. And we've broken out, actually I should mention, we've broken out chapter 1 in terms of how we met the requirements. Like I said, we're trying to strike the balance between readability and meeting the requirements. And so some of these detailed charts are in the appendix B, I believe. And so, but there should be a crosswalk table, again, that points readers to the area if they want to follow along directly with the guidelines. But this chart right here is showing the electric avenues that PGE owns and operates. We own and operate 7 of these electric avenues. Each site currently is configured with 4 direct current fast chargers and 2 level 2 charging ports. And so this shows load over time delivered at those stations, or energy delivered to those stations. And I should mention that these sites were all developed with sort of future growth in mind. And so they have some forward-looking investments to make future additions cheaper to integrate. And so that's those similar transportation electrification usage analysis can be found in the appendix. Next slide. And the takeaways of this chapter. So the distribution system is a key part of the energy grid backbone. That's a point that we aimed to elucidate in this chapter and also a little bit in chapter 2. So you'll see some of that in both of those chapters and throughout the plan, really. But our strategic asset management approach really helps to maximize, like I said, the investments that we make in the distribution system to have that trade-off of cost and reliability. So looking at customer value and ways to improve that, that's what we always have our eye trained on. And the changing nature of the grid with advancing DER adoption will likely require changes to past investments. And I think the rest of the plan will speak to our approach and how we see that actually materializing.
Thank you, Andy. Shadia, have we gotten any questions in the chat?
No questions in the chat. We have a little echo on your end, Angela.
Oh. Okay, so do we have any questions in the audience?
Please raise your hand so that we know if you have a question, so we can give you the floor to ask.
Okay, so we'll move, if there's no questions, we'll move on to the next chapter. And the next presenter is Nahit. Are you online?
Yes, I am. Can you hear me?
Yes, good morning.
Good morning. Good morning, everyone. My name is Nahit Shah. I am also a senior strategy and planning analyst on the distributed resource planning team. And I will be talking to you folks a few times today, and we will start our discussion by talking about the vision we have for the distribution system. And so before we get into the vision, let's just talk a little bit about the chapter. And Angela, if you could go to the next slide. The way we have laid out the chapter follows a sort of pyramid approach. And so what we have done is at the very top, we talk about our vision. And then we talk about how the goals that kind of tangibly define that vision. And then we talk about the initiatives that we are undertaking in order to achieve those goals, which will help us realize that vision, right? So we think about the vision, we think about our goals, and then we think about our initiatives, and that kind of pyramid is how we have set up both this presentation and the document. And that's the pattern that I think Angela alluded to a little earlier as well. Towards the end of the chapter, once we've talked about the vision, goals, and the initiatives, we get into some of our policy and planning discussions, and then round off the chapter with how we will monitor and adapt the plan as we move into future cycles of the DSP. With that, let's dive in with the next slide into the DSP vision. So we wanted to make sure that we are providing a clear vision, and we know that we want to transform the distribution system of today to a new type of distribution system. So the new type of distribution system is what we call the 21st century community-centered distribution system. And what we mean by that is that is a system where we will leverage DERs, whether that's through programs, non-wire solutions, virtual power plants, or any other mechanism that's applicable, to strategically deploy them in a way that drive decarbonization and community benefits, especially for environmental justice communities. And so fundamentally what we are saying is that our ability to deploy assets in a way to drive these values is a key part of what we envision in the future. And we want to also do that while improving our traditional metrics around safety, reliability, resiliency, and security, both physical and cybersecurity. So we know that that's a lofty vision, but we are confident that that is the direction we want to go. We feel good about the steps we are taking today, and we hope to bring everyone along in this vision, and are very open to hearing feedback on how we can improve. So to achieve this vision, what are our tangible goals? So that's the next slide. Our goals are threefold. We first want to try and advance environmental justice, and I will talk about I'll talk about all of these goals a little more in the upcoming slides. But fundamentally, it's talking about how we can deliver value to communities in a way that address energy burden and improve local economic impacts. The second goal we have is to accelerate DER adoption. We know that DERs are going to be adopted broadly, but we also know that we want to move quickly as a region and as a company, and we're going to try and try and accelerate DER adoption to the best of our abilities. And lastly, we want to maximize grid benefits. And what I mean by this is that when we talk about maximizing grid benefits, we are talking about a category of different benefits that drive customer value. So these include some traditional values such as reliability, safety, and some newer values such as decarbonization and elements of cybersecurity. And so again, I will go into each of these in a little more detail on the next slide. But to give you a sense of how we create a line of sight from our corporate strategy to our initiatives, we have created this slide. And so, as Angela said, we have our corporate strategy that impacts all aspects of our business. And then we have our sort of subsegment of the distribution system, which is a key element, as Andy alluded to. And we want to basically evolve this key element, the distribution system, to a 21st century distribution system, which achieves the goals of advancing environmental justice, accelerating DER adoption, and maximizing grid benefits. And so when we think about these goals and you say, okay, what does it mean to advance environmental justice goals? Like, well, obviously it makes sense. Like if you just brainstorm, so I'm just walking through how we were thinking. It makes sense that the community has the ability to actually communicate with the utility. That seems pretty straightforward. They should feel like they are engaged in the process. It makes sure that they feel empowered in some sense to reach out and kind of say, hey, this kind of DER product does not work for me. My community would benefit if you created a DER product that was slightly different in this way and that way. It makes sense that if they have the DER product, that they are able to easily connect to the grid, right? Like they shouldn't have to wait 10 months only to realize that that's not the right place to connect to the grid, or that's not the place where they can get maximum value, and things like that. Additionally, if they have the DER product, then they can connect it easily and they can communicate all of their needs. They still need the grid to be capable of actually realizing those benefits through a modernized infrastructure. So what I'm trying to show here is that if you brainstorm all the different ways in which we can achieve the goals, what we realize is that all of those pieces fall under 5 different buckets. And those buckets are what we have created when we talk about our strategic initiatives. And so the 5 initiatives we have are empowered communities, modernized grid, resilience, plug and play, and evolved regulatory framework. And I'll talk about these a little later as well. But that's functionally how we've been thinking. And so each chapter subsequently after this vision chapter is focused on one of these strategic initiatives. And so it talks about what we are doing today and what we are planning to do to a certain extent. And obviously, as the DSP evolves, the work that we do within these initiatives will also evolve. Next slide, please. All right. So let's start by talking about the first goal, advancing environmental justice. What we mean by this is we want to deploy our assets strategically to provide direct benefits to community and make sure we're applying an equity lens to understand how environmental justice communities are being impacted and make sure that we are providing maximum benefits to them when we do our planning process, right? And so why are we doing this? Well, fundamentally, the outcome here is that we want to reduce energy burden and we want to try and create local economic impacts. And so we talk about how we do this in the initiatives in the subsequent chapters, but that's kind of the goal here. Next slide, please. On the right-hand side here, we have our forecast as of basically today. I think all of you have seen this in earlier partner meetings where Andy Iden has spent a pretty significant amount of time kind of explaining the details. So I'm not going to go through each of these in a lot of detail, but I think the takeaways here is that all of these graphs are trending upwards over time, which means we are going to see more DERs on the system. We want to make sure that the system is both capable of handling these DERs and capable of optimizing these DERs. But in addition to that, a key addition to that is that we aspire to do more than this. And so from a flexible load standpoint or a demand response standpoint, we want to try and double the amount of flexible load assets that we have on the system by 2030. So we are currently trending towards 200, and we want to push that to between 250 and 500 by 2030. So we do want to move faster. We do want to move more aggressively, and we believe it requires a lot of consensus and a lot of working together for all of us in order to reach that aspirational target. Additionally, from a transportation electrification standpoint, in order to really drive decarbonization, we hope to maybe triple or quadruple the number of electric vehicles by 2030 compared to our forecast. So we really hope to work with policymakers, with partners in the industry, with customers, with all of you stakeholders here together and kind of chip away at all the barriers in order to maximize this impact. And so this is really key in terms of how we want to move forward as a company. Next goal, please, on the next slide. So maximize grid benefits. So what we mean by this is that we are basically building on our traditional utility value. So we feel that at this point in time, when we do our planning and we do our operations, we are able to account for safety, reliability, security, affordability, or fair and reasonable costs, if you will, adequately enough to expand that to make sure that we are also accounting for cybersecurity, decarbonization, and newer elements of resilience. And so we effectively want to make sure that our planning process is also accounting for all of this. And when we operate, we are kind of co-optimizing across all of these different values. So just to summarize, we've talked about our vision, and we've talked about the 3 goals under the vision: advancing environmental justice, accelerating DER adoption, and maximizing grid benefits. So how do we really achieve this? And that's the next slide, which is by creating strategic initiatives that are geared towards achieving these goals and realizing the vision. So as I showed you from the previous exercise, the initiatives will help us address different elements, both individually and together, working across each other. And that interaction, both as a single initiative and across the initiatives, will help us achieve the goal. So going through each of these one at a time. The Empowered Communities Initiative is fundamentally focusing on, if I had to put it in one sentence, I would say it's enabling equitable participation in the clean energy transition. That's to make sure that anybody and everybody has access to participate in the clean energy transition in a way where they can feel as empowered as anybody else in the region. And so that's kind of central to how we believe customers will be a large part of how we evolve the distribution system and how we transition to that 21st century community-centered distribution system. Grid modernization, or our Modernized Grid initiative, is effectively focusing on optimizing the grid with assets, right? Historically, we've been talking about having sight into what's happening on the grid, right? Having that resolution of what is happening on the grid. But today we don't talk about that. We talk about how we can optimize the grid for hundreds of thousands of different assets that are placed on the grid. And the Modernized Grid is what kind of enables that piece to come together. Resilience is the ability to anticipate, adapt, withstand, and quickly recover from disruptive events. I think we have all talked about how important resilience has become over the last few years, both locally and nationally. We believe that it's important enough to be an initiative by itself. We will be talking about this as its own chapter, and Joe Boyles will be talking about it in this presentation a little further down the line. Plug and play, as the words kind of suggest, are the ability to improve access to grid edge investments to accelerate customers' clean energy transition. What we mean by that is, I, as a customer, would like to know, where should I put my DER? Where can I not put my DER? How long will it take to interconnect my DER? All these pieces to easily connect to the grid must be readily available. And so to create that kind of future where people can connect to the grid in a manner that is seamless, with the knowledge of how much value that location can provide and how much value that kind of resource can provide, is critical in enabling decision making for DERs on the system. And that's what we aim to achieve with the Plug and Play initiative. And finally, all of this has to be supported by policy, right? Like we need regulation that is consistent and aligned in a lot of ways. We need new regulation that helps accelerate some of these pieces. And so we have basically written about an evolved regulatory framework that talks about how we as a society can change regulation in order to move in a certain direction faster. And that direction is the direction of the vision. With that, we can move to the next slide. And so before I wrap up the chapter, I just want to talk about how the DSP interacts with other planning activities and budget development activities. So we have the DSP interaction with the IRP. And fundamentally, this is where resource planning takes place. So we provide resources, the distributed resources, that are within the purview of the distribution system to the integrated resource planning team. And so what we do is we provide it in 3 different ways. The first is we provide cost-effective distributed energy resources. So they know that, hey, these resources are going to be available, and they take that off their net load forecast and account for those in their resource planning. Second is we provide them with non-cost-effective demand response, distributed energy resources. And those are to ensure that we are trying to maximize the number of DERs we are accounting for in our resource base. And finally, we also give them a sense of the EV adoption and PV adoption that's going to happen from a market standpoint. So not necessarily induced by PGE, and that helps them understand what are the implications on the forecast. From a T&D perspective, the DSP will help provide locational elements across the board, and those locational elements will help improve the distribution and transmission planning process. This can be this can focus on impacts on specific feeders in terms of how they will impact the substation and the system. Due to DER adoption, it could be due to non-wires, and it could be due to just general load and DER adoption broadly across the system.
Hey, Nahid, you're at time, so
yeah,
just going to give you 1 minute left.
Yes, and just to wrap it up, the last one is the interaction between the DSP and the utility budget. We know that we need to modernize the grid. That's going to drive investments. We are aware of that. PGE does have a rate case that's ongoing that talks about a lot of this as well. So we know that that is going to be a driver, and that is going to be a consistent driver. And we believe that there are significant ways in which we can add value by modernizing our grid, and we'll talk about that in upcoming chapters. Additionally, locational improvements that are driven by DERs will have an impact on the grid, like protection equipment and interconnection and things like that. And lastly, non-wires have an interesting relationship with the budget compared to traditional solutions, which we can explore further and is detailed in the DSP. With that, we can move to questions. Oh, sorry, chapter takeaways. So I just want to reiterate the pyramid structure that we had. We start with our corporate strategy, and then we have our vision at the center of the distribution system that we're trying to achieve. We have our goals that we have outlined and our initiatives that we've talked about. And fundamentally, what we're going to do is talk about each of these initiatives today and evolve these initiatives as we go forward. And that's where our discussion is, right? Like an action taken today is within these initiatives. They help achieve our goals. They help realize our vision. And that's consistently what we are trying to do. And that's where we can have rich discussion. With that, we can move to questions.
And so it looked like we had one question in the chat, but it was answered. And I do want to point out that the subsequent presentations will discuss either how we're beginning to approach some of these things. We may not have actions around them today, but we starting to form a plan that meet the strategic focuses, right, Nahid, that you just mentioned. Some things we already have in place. So there's kind of a spectrum of where we're at today, maturity-wise, across the board for some of those strategic initiatives, and we will get into more details on those after the break. Is that fair to say?
Yes, absolutely.
Okay. Did others have questions before we move to break? Okay, I think our break was actually, I'm just doing a quick time check, was, till 9:10. So why don't we come back at 9:10 and we'll begin the next part of our presentation. Okay, Jen, are you ready to go?
I'm here.
Hi. Okay,
Hey.
I'll get you set up here.
Okay, thank you.
We'll begin in just a minute.
Sounds good.
All right. So thanks, Jen, for joining us this morning. Let's get started.
Sounds good. So I spoke a little bit earlier, but I didn't introduce myself. I think we're kind of bad about that sometimes. My name is Jen Lathu. I use she, her pronouns. I work as a community outreach staff in the DEI office at PGE. I am one of the primary contributors to Chapter 3, which is around empowering communities. And so I'm going to spend a little bit of time here talking about what is in the chapter, similar to what other folks have done here. If you want to advance the slide. Thank you. So a similar slide to what you've seen in the previous chapters, this really outlines the scope of work in reference to community engagement that is in this chapter. Where we are currently is stage 1. That's where we are today. We've kicked off or began our community engagement journey. We have a plan. We better understand what we need to do and why. Within stage 2 and 3, we're really getting into the integration of that feedback and the learnings and continuing to engage with communities to better understand the needs and opportunities that exist, and eventually working with community around project identification and implementation. The key takeaway here really is that this is a multi-year effort with stages that build upon each other, and our intention really is to do this in a way that enables equitable participation and transition into clean energy. You can advance to the next slide, Angela. Thank you. So this is really just speaking to the fact that we know as PGE, as an essential service provider, we acknowledge the importance of understanding and engaging our customers and communities. This chapter represents our intentions to do this while working together to develop solutions and making sure that we are prioritizing community benefit and access to clean energy. With that, we take inspiration from Zero City's work that was done by City of Portland's Bureau's Planning Sustainability and Race Forward to pursue the twin goals of racial equity and decarbonization. Recognizing that we always must acknowledge and address disparities and the impacts that are within our communities, and especially in any transition, these are perpetuated. And so we're acknowledging this need to address and make sure that that is not something that we do within this process, and that we are intentional about that. So making sure that we keep this in mind, I think that the pursuit of these twin goals around racial equity and decarb are a really fundamental theme of this chapter, and I think throughout the DSP plan in as a whole. You can move on to the next. Thank you. So just kind of orient you to the chapter and what to expect. There are 3 sections: human-centered design and planning, there's the community engagement plan, and then there's the learnings to apply to part 2. When we talk a lot about human-centered design and planning throughout the DSP, and again, this is because we acknowledge that there are inequities in our electricity system. And to begin to overcome them, we know that we have to engage and learn from those closest to the issues, because reality is that they're often the closest to the solutions. And oftentimes when we think about the grid, we really center on the technical aspects, such as the transmission and distribution lines, substations, feeders, and meters. When we're talking about the human-centered aspect, we're really centering on who is behind that meter, what community is served by that substation and or feeder. How we intend to really implement that human-centered design in the planning is outlined in our community engagement plan. That includes our framework for how to do the work with inspiration and contribution, all founded in our partnership with some community-based organizations that I'll speak to in just a bit. And then it also includes and outlines our goals, objectives, and outcomes that we seek to achieve. The last section of the chapter includes what we've learned so far and what we intend to address in the next part of DSP. Thank you. Oh, there it is. So this image here is called the spectrum of community engagement to ownership. It comes from movement strategy. It may be familiar for folks who participated in the DSP in its early stages, back when Oriana from Verde and Charity from Community Energy Project shared it as part of the community engagement best practices. It's also leveraged in the Zero Cities work and other aspects of best practice work around community engagement. This is another element of inspiration for how we think about and plan to do our work ahead for DSP. We know that historically utilities really have operated kind of in the left side of the spectrum, so in the ignore, inform, consult. And our evolving approach to be more human-centered relies on us working to build trust and relationships with our customers and communities. And we understand that that happens over time. And so our goal is to move from left to right on this spectrum, and which really gets into more of the collaborate and, when appropriate, defer to community to understand, how to best serve, how to best create solutions that are beneficial and that meet their needs. And so if we want to move to the next slide. So this is also probably a little bit familiar in terms of the slide outlines the requirements from the commission and how we have or expect to respond to those requirements. So in terms of what is our action, I'm not going to spend a lot of time here because a lot of our actions are identified and we get a little deeper into that in the next few slides. So I've talked to this group previously about our workshop in the past. Really, our workshop approach, if we are thinking about this from how we've done things as a requirement, we were asked, we have to have 2 workshops prior to each filing. As of now, today, I believe we've had 8 partner workshops, which is where we are today, which includes kind of what we refer to as traditional stakeholders. And those are folks who have engaged with us, are used to engaging with us, maybe have some technical expertise, and come into this space to with some existing knowledge and different kind of motives and understanding that includes, regulators, customer advocates, utilities, and others. And so that is an aspect of how we plan to engage in kind of a traditional way that we have always done things, and acknowledging that. But the deeper context here is that on the left, we talk about making sure that we are also reaching and engaging and including those that we have not traditionally reached in the past and made place for and heard from. And so when we're talking about that, what we're saying is making sure that we're fostering procedural equity and really focusing on environmental justice communities. And so kind of building on that and how we got here today and built into this plan, is you can advance to the next slide, please. We've talked about this in the past. We've highlighted the work that is, I think, in the last workshop with Community Energy Project, Unite Oregon, and the Coalition of Communities of Color. hosted 2 workshops back in May that are really focused on community. And the way we've thought about how we respond to these requirements is to go to do what we know is necessary, not necessarily in compliance or the minimum. And so what we sought to do is partner with our community-based organizations to provide some capacity so that rely on them for their expertise in being able to reach and convene community and translate materials. We often have wonky language and don't necessarily know how to best communicate technical ideas. And so partnering with communities to do that in a way that is informational and provides that information and context to both the community-based organization and the communities that they serve and that we are convening. So we compensated the community-based organizations, we contracted them to do this work. Community Energy Project's focus was really to make the materials accessible, to translate our kind of wonky energy concepts into the energy / DSP 101, and also some elements of climate resiliency into it. Unite Oregon did a lot of the recruiting and convening. They acted as the facilitators during the workshops, designed the surveys, collected feedback on our behalf, and then CCC, or Coalition Communities of Color, they provided us with recommendations via report. That report was really fundamental to our community engagement plan and to how we think about what we will be doing to ensure that we are engaging and have that human-centered design and planning aspect of the next phase and moving forward into DSP. The plan was developed in partnership with them, a lot of inspiration from the report and recommendations that were provided. And then we went through a review process with them as well. We can move on to the next slide. So really the chapter takeaways here, as we talked about, right, is that what we seek to really do and our plans for community engagement really require us to develop some competency, us meaning PGE, and to understand that where we are today, we acknowledge that our maturity around diversity, equity, and inclusion is pretty much in its infancy. We have a lot of work to do. We understand that there's a lot of work ahead of us to develop our own competencies to truly understand this work and to achieve what we intend to achieve. And so that is built into our plan. Also recognizing that a big piece of this is understanding our own application of the equity lens and making sure that we are able to apply that to ourselves and to the work that we do, the decisions we make. So that's a huge part of it and something we seek to achieve. And in part 2, that really looks like making sure that we are frequently communicating, that we have built-in feedback loops, that we follow through on what we say we are going to do, that we engage early and often, and again, making sure that we're transparent around what is actually happening. Something, especially when we're looking to engage communities, is making sure that there is that follow-through piece. Another focus area and part of this chapter is really making sure that we can gain meaningful participation from environmental justice communities. And that really looks like ensuring that we are leveraging their expertise by compensating them, making sure that we are continuing to engage and build relationships, making sure that we are providing mutually beneficial tools and information and context, and getting to the point where we can do this work authentically so that we have our understanding and so that we are engaging in a way that folks want to engage with us. The last focus area, and really important, is making sure that we're focused on a diversity of data. It's really important to us that we are looking at data to inform what we do. And so we are in the process of exploring those options currently. And what we hope to achieve is making sure that we have clarity around understanding community needs, understanding who lives within communities, and making sure that we're doing all of the work is supported and informed by data that provides the right level of information. I can move to the next slide. So this last slide for me is really around two aspects. So we talked about a two-prong approach early on, and throughout, anytime we really talked about what we were hoping to do with community engagement and kind of the DEI aspects of the DSP. And so this learnings and feedback slide here is really focused on two pieces. We know that part of the work is community engagement. The other part speaks to kind of that bigger goal around competency, and so applying an equity lens. And so applying an equity lens to our work, we know that we have done that we've started to do that, and that we have to continue to do that through the baseline data requirement area and through the hosting capacity analysis. We also know that we have to now do something about that. And so as we think about that, and we think about the next phase of our work and what to expect, I think it's really important here to acknowledge that since this is new work and we are really building a muscle around community engagement, around engagement with environmental justice communities, that we'll make mistakes, that we're not going to be perfect in what we do, but we are our commitment is to do better and to learn and to grow and to listen and to take what we are learning and the information that we are collecting and apply it as we move through this process and evolve. And so I guess what I would leave with you here is that is the intention, is here that we acknowledge at PGE that we have a lot ahead of us, and that it's going to require a lot of all of us, and that we are willing and committed to doing the work, and we understand and are not shying away from the fact that it's going to be hard and it's not going to be perfect. So with that, we look forward to really applying kind of what the gaps are that we determined in this first phase of community engagement, and look to apply that in this next phase, and then the following, and then the subsequent stages thereafter. And then that is all of my slides. So I don't know if anybody has any questions.
We do have a question in the chat. And sorry, I hear myself echoing, but Oriana, do you want to ask your question?
Sure. I just want to show appreciation for the thoughtful approach PGE is taking. But I would like to better understand what work has been done to do repair with Unite and CCC and CEP after the harmful incident that occurred earlier. It would be helpful to understand, if you're continuing to work with those organizations, what accountability you're taking moving forward, and maybe also potentially to hear from those organizations directly in their own words, if they're present, whether that reflects their understanding as well.
Yeah, thanks for the question, Oriana. I think it's really important to acknowledge that the harm that was done, largely part of kind of not acknowledging that we do things a certain way, and that that's not necessarily the way that is beneficial for others. And so as part of that learning, the operating agreements, I'm not sure if you were on the call when we kicked off the meeting, but a huge setting the stage and making sure that the accountability portion is understanding that we have to do better to protect spaces, especially when we bring different folks into the space. So we are part of the accountability, and something that we have done is making sure that we have agreements that we are sticking to, and that we are being transparent around those. In terms of what the relationship is with CCC Unite and CEP, we are still working through that, and we've had continued conversations. We've definitely acknowledged and started to, we've had conversations around what that repair looks like. And for right now, it looks like space and, respecting timelines around engaging. And so we are continuing to work with CEP. With Unite, we are figuring out what that could look like. There, a lot of their own priorities, with CCC as well, a lot of their own priorities and our timelines, they don't quite match yet. And so what we've really gotten to is they've asked us to continue to keep them in the loop and to share resources. And so we've been doing that when they are becoming available, and share information, the level of information that is relevant for them, so that they're not having to shift through things. Because they are interested in continuing to understand a lot of the energy aspects of this work, and kind of this engagement in the next piece. But outside of that, they have asked us to include others as well, and to engage with other CBOs within the Oregon Just Transition Alliance, to start to think about the DSP in the next phases, like part 2 and so forth. I'm not sure if that completely answers the question, but there has been some repair work to have conversations to respect what the wishes are. And I'll pause there and see if there's a follow-up question, Oriana.
No, thank you for that really just transparent and vulnerable answer. I know it's not easy sometimes to talk about something difficult like this, but I appreciate PGE being willing to just share a little bit more. And I'm glad to hear that there's repair work being done.
Absolutely, and thank you for asking, because I think, as I said on the last piece of the presentation, is when we are coming up to speed and undertaking our own journey, I think that it's we will make mistakes. And I think the best part we can do the best thing we can do to address those is to be transparent, to learn from them, and to make sure that we apply those learnings moving forward. So we'll continue to do that. So thank you for asking.
And Jen, do you mind if I add something to this question? Jen has done a fantastic job of not just working with the CBOs, but also working internally with our teams. And so regardless if we're able to re-engage with those organizations or not, we are committed to learning. Like Jen mentioned before, we are starting to apply the maturity model and understanding just where we are, and making sure that we have training internally to have a better understanding of how we approach things and how we truly should be engaging with communities. And so we are committed to looking inward, regardless of the situation, and Jen's done a great job of keeping us accountable to that, but also just really educating us, because I think that the organization here, there's a lot of really good people who want to do good work, who just don't have the expertise or the skill set to engage in the way that we want to long term. And so Jen's been really helpful in bringing us along and teaching us. So I think we're really early in the maturity model there for some of us, but most people, Oriana, really do care about this work and want to learn. And so I think that's going to be the biggest growth area for us next year. Jen, what do you think, just internally?
Yeah, we definitely have a lot of work to do, but we also have a lot of interest and passion, and I think our depth in understanding the why is really been, I think that's developed quite a bit. And so I think we have a lot of work ahead of us, but we have a high commitment too. So I think that there's a lot of opportunity for us to get better and do better.
And for part 2 of the DSP, we are committed to continuing to work with community-based organizations that are interested in working with us. So feel free to reach out to us if you would like to partner with us. We're trying to think of new ways to engage for next year. So feel free to reach out to Jen if you have ideas there, if would like to participate in that. Any other questions? All right, well, Jen, you're super concise and on time, so I have to give it to you. Thank you for your time, and we'll move on to the next section of our presentation. Welcome back, Nihit.
It's good to be back, Angela. Thank you. Hello again, everyone. Just to make sure that folks that may have joined midway through the presentation, I'm introducing myself. So I'm Nihit Shah. I'm a senior analyst on the distributed resource planning team. And I will be talking us through our Modernized Grid initiative, where we talk about how we are building a platform for participation. Next slide, please. As we have with each of the chapters here, we wanted to just start by giving you a sense of what the chapter looks like. We have set up the initial sections of the chapter to sort of talk about how the scope of modernizing the grid has evolved and what the desired outcomes are. Then sections 4.5 and 4.6 are some of the key ones where we talk about what the smart grid investment opportunities look like and how these opportunities can really help deliver value. And then in 4.7, we talk about the investments that we have planned on the books or we have planned more or less in PGE sort of mind, if you will. And we talk about how we're going to do them, when we are going to complete them, and what kind of impacts those will have. And finally, we round out the chapter with some R&D work. So in today's presentation, I will focus on what it means to have a modernized grid, and then we'll dive into some details there. So we won't be touching upon every single element because it's a rather long and quite technical chapter, but we will touch on some of the key points. Next slide, please. Oh, sorry, yeah, the previous one. I think we've gone. I think the one before this. There we go. All right. All right.
Are we good, Nihit? Sorry,
yes,
I'm
we are.
a facilitator. Thank you for bearing with me. I don't know how to use PowerPoint.
I think this is the little jovial bit that we do in between to just keep it light, you know, between the heavy topics. So appreciate that, Angela. And so let's just talk about how the modernized grid kind of links back to the goals that we were talking about, right? So obviously there is some sense that we need to modernize the grid and like there should be this central system that is like able to control hundreds of thousands of devices or whatnot and like try to optimize them. There is that idea in most people's mind that is kind of some future. But what does it really mean, right? Like and the way we think about it is while the modernized grid has several different outcomes and goals that it's achieving, some of the key ones are the ones that we've listed here. So we know that having a modernized grid helps us optimize DER performance and other grid assets in a way that can sort of help us push further into our decarbonization goals and targets. And so that's kind of one of the key elements of a modernized grid that we wanted to highlight. Additionally, having sensors, telecommunication devices that can communicate with the sensors and having centralized systems that can operate all of that can help us kind of predict outages, try to limit the outages to certain sections of the feeder and things like that as a way to try and minimize the number of customers that are impacted by outages, thereby improving elements of resiliency and reliability and helping us keep the system sort of functioning even through harder conditions. Finally, we want to talk about security and assisting environmental justice communities. From a security standpoint, we've historically predominantly thought about physical security, but now security is sort of a two-pronged approach where it's physical security and cyber security because of the virtual layers that exist in the grid, and I'll get to that in just a little bit. And finally, assisting environmental justice communities and just more broadly, all customers. When we think about how different assets can be deployed on the grid, like smart meters, for example, they enable different tariff structures like time of use, or allow us to provide analytics to the customers and things like that. Those can help folks understand better how participating in certain programs or certain offerings from PGE or others will be able to help them reach their goals, whether their goals are to be green, whether their goals are to reduce cost, whether their goals are to ensure that they have minimum voltage fluctuation for example, for some businesses. And we feel like this is particularly important for environmental justice communities because it really gives them some of the tools that we think about, because they don't care about what technology or things like that. They care about the outcomes, right? Like we all care about the outcomes. And so making sure that those outcomes can be realized, I think is enabled through technology. And that's what we want to highlight here. Right. Now let's get into it with the next slide. So I think I was mentioning this a little earlier, but to dive in with a little detail, I think 20 years ago or few decades ago, more than a few decades ago, we used to send folks out into the distribution system to understand what was happening in the distribution system, right? Like to get visibility, we had to send out people into the world and kind of measure things at different places and kind of read the meters and things like that. Maybe a decade ago, we started talking about, hey, we can modernize the grid to improve our visibility of what is happening on the grid. But today, when we talk about modernization of the grid, people assume that visibility is a given, right? Like people assume that the utility already is aware of what is happening. To a certain extent, that's true with the introduction of SCADA and AMI. But today, when we talk about modernizing the grid and we talk about a future grid, people talk about how the grid is intelligently using all the elements within the grid, right? And so it's a lot about control and optimization. And so what I'm trying to show here is that over time, the scope of modernizing the grid has been evolving. And as the scope evolves, this is sort of today's iteration. But we need to create a framework that allows us to not only build to what we think is modern today, but also continue to build on what we think is modern in 5 years. And so what we have done is we have reviewed best practices from the Department of Energy, other utilities, consultant organizations, and a whole bunch of others, and spoken to a whole bunch of people to understand, hey, what's the best way to think about this? And the large consensus is that we should think about the grid as a platform. And PGE has historically been thinking about the grid as a platform. We're just kind of reinforcing that that's still the right way to move forward. And the way we think about the grid as a platform is that we build ground up. So as you can see the layers in this graphic here on the right, you'll see that the physical infrastructure, the physical grid, is at the very bottom. And as we move forward, there are layers in between where we finally on the top reach to the customer ecosystem, right? So historically, there were fewer layers in between the customer and the grid, and now there are more layers, and in future, there might be even more layers, or there may be even fewer layers. We don't really know to a certain extent, but we believe that this layered platform approach is how we should be thinking about modernizing the grid and how we think that we can sort of address and adapt to the evolving scope of modernizing the grid. So keeping that in mind, we want to talk a little bit more about this graphic on the next slide. So instead of going into each layer in detail, first let's talk about some of the high level points, and then we'll go into each layer in detail. So we can basically classify all the layers that are kind of horizontal here, the ones that are longer in width, as either foundational or advanced. By foundational capabilities, what we are talking about are core functionalities that are needed to improve resolution or basic understanding of the distribution system. These foundational capabilities are more likely to follow a least cost best fit approach when evaluating how we should implement them. And so an example for this, I think one that is common for this group is for example, cost effectiveness or sensing and measurement devices, right? Like having a cost effectiveness tool or a planning tool doesn't deliver value to a customer directly. But obviously, it is a critical element in eventually delivering that value, right? And so a planning tool by itself cannot be subject to a cost benefit analysis because it doesn't necessarily deliver that end value to the customer. There might be some benefits in terms of reduced computational time or reduced number of resources and things like that, but it's not fundamentally adding value to the customer. And so the DOE kind of recommends, and this is adapted from there, that these kind of foundational investments follow a least cost best fit approach, which is usually sort of procured through like an RFP style process or something similar to that effect. Advanced capabilities, on the other hand, build on these foundational capabilities to actually deliver value in most cases. And so since they deliver value through a specific asset, they go through cost benefit analyses, right? Like if we want to deliver value about conservation voltage reduction, we have options. Do we use smart inverters? Do we use capacitor banks? Do we use other load tap changers or whatnot? And that at that moment, when we have those kinds of options, that's when we do a cost benefit analysis. So that's how we think about these pieces. And as you can see from the figure, there isn't sort of a clean cut between foundational and advanced. They kind of overlap, and it's not really neat. And that's just the nature of how the modernized grid would be. Finally, I want to talk about some overarching capabilities. So both foundational and advanced elements have overarching sort of capabilities within, and those sort of span across compliance, cybersecurity, and workforce strategy. And so what we think about is that when we are considering an investment, say in telecommunication or grid management systems, we have to account for compliance, cybersecurity, and workforce strategy. And these are some of the more key elements that we need to think about as we go through developing the capabilities of each of these layers. All right. With that, let's dive into the layers. So we aren't going to talk about every layer today. So we've decided to stick to a couple that we think are key and that we think will be a good choice for discussion. And so we're sticking with planning and engineering and grid management systems. Starting with planning and engineering here, the way we kind of describe it is planning and engineering is not a single tool. It's not like a single function. It's actually a collection of different tools that are integrated in a seamless manner, such that you can perform system planning and engineering functions across the board repeatably and scalably. Why we need this? I think it's relatively obvious why we need planning, but just to kind of explicitly say it, it helps us optimize our investments and make sure that we are deploying assets that drive maximum value. An example of that is non-wire solution. Example technologies that kind of help us get there. In this case, technologies can also be considered tools, and these include examples like SIME, which Andy mentioned is the tool of choice at PGE currently. Other examples are cost effectiveness tools, or NVLio, Adopter, which is PGE's now in-house DER forecasting model, and other market solutions such as Opus One, Kavala, and whatnot. The functions these tools can perform as an aggregate across the board include everything from identifying the need on the system through different reports, providing solutions, providing locational net benefit analyses, performing non-wires analyses, hosting capacity analyses, and forecasting and various other functions. So we just wanted to kind of highlight that. Next slide, please. The costs and benefits here that we want to discuss are the pieces that have the costs and benefits. So obviously we want robust tools. We want to make sure that these are well integrated. We have the right set of engineers who can use these tools, and the fact that these tools are interlinked. So these are starting to become large complex systems. So we need to think about how a change in one system kind of impacts all the other systems downstream. And so we need to make sure that we have the right people to run the systems, and we have the right IT integration to reduce the overall cost of running these types of analyses and studies. From a benefit standpoint, obviously planning helps us achieve our goals. That's why we have a plan for our distribution system, and that's why we create plan for our resources and things like that. We want to make sure that having the right tools enable us to accomplish our goals faster and more optimally than we would otherwise. And from a maturity standpoint, we have leveraged a smart grid maturity model that's pretty popular in the industry. I think it was developed by Carnegie Mellon. And so on that maturity model, there is a scale from basically 0 to 4 or 5. I'm sorry, I don't recollect right now. And we feel we are at the enabling stage, which is basically closer to a 1 and a 2 on the scale. And so fundamentally, we feel like we aren't where we want to be in order to be able to plan for the grid optimally as we have defined in our vision. And we want to move ahead and kind of upgrade our planning tools in order to be able to do that kind of complex planning. The barriers we face are that there aren't many tools in the market that are available to do all the things we want to do. And while we all might agree on the vision, the realization of the vision becomes harder because sometimes we don't have these market solutions. And it's impossible to have a planning team that does both planning and develop tools for planning. So those kinds of barriers need to be accounted for. So we've talked about this at a high level now from planning. We've talked about planning and engineering at a high level. So what are we actually doing? And that gets to our planned investments. And we can move to the next slide here. So in the DSP, we talk about some of the higher level planning and engineering investments that we have taken up. So we're doing work on the adopter model, which, as most of you are familiar, is our DER forecasting model. And so what we effectively focus on is currently providing a system level forecast that, as I mentioned in chapter 2, we provide to the IRP. And moving forward, we will provide locational adoption in part 2 of the DSP, and then hopefully evolve the tool to do some cool adoption work around non-wires, specifically how non-wires change adoption in the grander scheme of things. We have another project called the Next Generation of Planning Tools, where we are currently gathering requirements. This is functionally talking about a large set of tools as well. So it's a subset of planning and engineering, but it is a large project. And so everything from us needing, say, time series power flow analyses, or new types of safety analyses, or new types of voltage analyses, all of these pieces that are needed in order to perform the functions that we highlighted earlier. So if we want to provide some kind of seamless interconnection process or enhanced hosting capacity, we need these types of tools. And so we're doing some requirements gathering for some of these, and we should be able to then deploy them and therefore drive that planning value into 2023 and beyond. The next one is the DER data management system. Previous time, yeah. The DER data management system, or the demand side data management system. And fundamentally, this is a large database that has a lot of data associated with DERs, and that's what acts as the source for a lot of the planning activities, in addition to AMI data, SCADA data, and a few other data sources. And lastly, we've taken up some work related to non-wires and cost effectiveness, where we are trying to increase our capabilities to be able to perform non-wires, both on a repeatable and a scalable basis. And we want to upgrade our cost effectiveness to more holistically consider the impacts of our investments, not both from a utility standpoint, but also from customer and a societal standpoint. Moving to the next slide here, we want to move to the next capability, which is the grid management system. So I just want to take a quick minute to provide some commentary, which is we talked about planning and engineering, which is just one capability, and we talk about most of the capabilities we've outlined in the graphic in the DSP. So if you're curious about, say, sensing and measurement or something like that, you can dive into detail for those specific capabilities. Grid management system, at the base of it, the way I think about it is sort of the brain of the grid, right? It's a set of computer-aided tools used by operators to monitor, control, optimize the performance of the distribution system. So just as the brain needs neural pathways to control the muscles, we have telecommunication devices that help connect the brain, that is the grid management system, to the field assets, which are the sensing and measurement systems, right? So the muscles are kind of equivalent to sensing and measurement devices. The nervous system is kind of equivalent to our telecommunication network, and the grid management system is like the brain, right? So you basically use all three when you are trying to control your muscles, and that's fundamentally similar to how we are building the grid here. And to do so, the central elements are the advanced distribution management system, the DER management system, the outage management system, and the demand response management system. And these technologies work together in a way to try and optimize the grid using all the different assets. And so some functions that we can talk about are things like optimizing the grid for carbon intensity, or trying to perform voltage regulation on an ongoing basis, or have specific voltage regulation programs like conservation voltage reduction, and so on. Next slide, please. From a cost and benefit standpoint, obviously the software is a large cost. A software that's capable of monitoring, the hundreds of feeders that Andy mentioned and the hundreds of substations that we have in a manner that is optimal while delivering value, and we are adding more values that we need to optimize for. It's going to be a complex computer, and that kind of software system needs to be robust, and it needs to be secure against cybersecurity threats and things like that. So that's definitely a large cost. But then there's the hardware cost, right? Like the muscles, which is the sensing and measurement, and the nervous system, which is the telecommunication. So having the brain would require us to be able to control the devices. And so enabling the systems that help us control those devices are critical. So the software and the hardware elements all come together to realize the value for grid management systems. The benefits obviously are the ones that we realize. So we plan for certain benefits, and the grid management system is where we realize those benefits, right? So we say that the non-wires will actually defer a traditional investment by 3 years. This is where those 3 years are kind of realized, right? This is where our planning becomes a reality, and this is where customer value is being realized. And so this is obviously really important because this is the final piece that kind of enables a lot of what is happening. From a current maturity model, you can see that we are a little further in the model where we are integrating instead of enabling, which is sort of one step higher. And the reason for this is because we are investing actively in our ADMS systems, and we are upgrading that. And I think that's also pretty correlated with what's in the general rate case this time. Finally, the barriers here are that this is a complex system, both from a software perspective and from a hardware perspective, in terms of having all the devices, having all the telecommunication, making sure they are actually providing signals all the time, even when there are outages and things like that. There needs to be a lot of investment in order to enable this system. And we need to balance that with rate impacts. We know that this can deliver value, but we need to think strategically, and we need to deploy it in a way that balances rate impacts. And that is something that we're very cognizant of, and something we actively think about when we think about these investments. So coming to the planned investments, we can move to the next slide here. We have our grid management system. So this, again, coming back to our analogy, is the brain. So we are currently moving from our basic ADMS to our advanced ADMS functions. So that's basically ADMS phase 1 to phase 2, if you will, where we will be able to perform more kind of complex functions on the distribution system, such as automated switching and a few different things. We also want to introduce new schemes such as fault detection, isolation, and system restoration. And then we will then have better integration with our DERM system or our DER management systems, hopefully at the start of 2023, where we also focus a little bit on our outage management systems and better integration of our transportation electrification work. And we hope that over time, we are able to sort of create some optimization and then grow the scope of that optimization and keep growing that as time goes on. And we are able to account for more constraints on the grid and more values that we can provide to the customer. So now that we've talked about the brain, let's talk about the network that sort of supplies the brain with the information and that like takes the information from the brain and kind of does the action. So the next slide talks about some of the equipment we have on the feeders. So we talk about distribution automation, which is actually a set of 3 different sort of initiatives or elements, if you want to think about it that way. We have our fault location, isolation, and system restoration, or FLISR, which tries to isolate a fault within a section of a feeder, thereby preventing everyone on the feeder from having an outage, everyone downstream of the feeder from having an outage, and trying to restrict the number of people that are impacted by an outage, say from a tree falling or things like that. And also it provides automatic system restoration for some of the smaller things, such as a small branch falling on the wires and causing a trip. We talk about voltage and reactive current, reactive power optimization, or volt-var optimization, where fundamentally we are trying to optimize the voltage across the system in a way that causes minimum disruption to the customer while reducing as much peak energy needed to supply, to reduce the amount of peak energy that is needed on the system. So that's the balance that we try to hit with volt-var optimization. And as you can see, we're trying to implement it in our smart grid testbed right now. And we will hope to sort of scale that solution moving into 2024 and 2025. And as you can see, setting up the devices for volt-var to a certain extent are a foundational investment. But then deciding whether those are the solutions we use to perform volt-var as opposed to other solutions is a part of cost effectiveness, right? So having some devices on the system that are able to do multiple functions are a least cost best fit investment, whereas deciding to use that device for that function, such as volt-var optimization, is a cost benefit decision, which we will apply when we reach that point. Similarly, for smart fault circuit indicators, we are at a stage where we are setting up these indicators such that we know where the distribution system has faults. And as you can imagine, this is a good technology to apply in wildfire areas. And so that's kind of our focus. We want to try and hit as many circuits as we can that are in our PSPS areas and see if we can really leverage the value of these smart fault circuit indicators. And then hopefully we can scale some of the abilities of these solutions based on their cost effectiveness moving into the future. So we've talked about the feeder. Let's talk about the substation, and that's the next slide. So from a substation standpoint, we can think about it broadly in 2 categories. We talk about automation, which is predominantly SCADA. And we know that we have some non-SCADA substations, and we have to replace some legacy SCADA systems. And we're going to do this opportunistically. We don't necessarily think that there is a need to have an initiative where we go out and add SCADA just because we can check off a box that says 100% SCADA. We are very close to 100% at this point, and we feel like we can just be opportunistic as we go about doing this and also consider other priorities in terms of investments. Again, getting to that point where we are balancing the rate impacts and the investments needed. The second category here is protection equipment, and we want to make sure that we are replacing relays and having different types of protection protection elements within the substation. And as you can imagine, having these kinds of systems working at their peak condition is obviously required in areas that have possible issues, and that's where we are focusing on the wildfire zones in the short term, and then we will expand that program as we move along. With that, we can move to the next slide. And this, again, is kind of highlighting the cost-benefit approach that we just talked about. And so this just goes in a little more detail and says that this is the Department of Energy's recommended framework, and they talk about how some investments need a least cost best fit approach depending on where they are in the platform, and some investments require a cost benefit approach. And as I mentioned, we are trying to update our cost benefit analysis in order to perform these types of investment decisions. And so with that, I think I want to wrap up the chapter with our takeaways on the next slide, which is modernizing the grid fundamentally is an ever evolving scope. And we feel that a platform-based approach is the right way to continue to modernize the grid. We have done a lot of review and spoken to a lot of folks, and we encourage all of you to do the same and provide feedback and make sure that we are incorporating as many best practices as we can as we develop our modernized grid. And lastly, in the DSP, we have provided both high-level details on what it means to have each of these capabilities. And then we've also talked about planned investments within each of these capabilities as is applicable. And so with that, we can move to questions.
And we have one question in the chat. Oriana, would you like to ask your question? I know it was at the beginning of the presentation, so I can go back to the slide if that's helpful as well. And Nick, we'll get to you in a second. We'll do Oriana, Nick, and then Angela. Well, we might have lost Oriana. Do you want me to read the question for you, Nihit?
Yes. Okay. I think Oriana is back.
Oh, okay.
Oh, sorry, never mind. Okay.
Okay, so Nihit, can you explain how a least cost investment model will be responsive to environmental justice AMI data that you're collecting or we're collecting? And typically, least cost models do not lead to benefit for low income and EJ communities.
Yeah, so let's think about what we are saying when we are talking about least cost best fit models. These are foundational and basically help get us to the point where we can deploy assets on top of these that actually deliver value, right? And so they themselves are not necessarily focused on delivering value to the customer. But that said, what we want to do is that when we are considering least cost best fit, a part of that best fit is to ensure it's accounting for the needs of the environmental justice communities. So I mentioned that we would do that through processes like RFPs, and it is incumbent on us, as Jen has mentioned, we're trying to take into account of these needs. We want to include these types of needs in that process and say, hey, if we are going to get a tool, we want to make sure that we can add things to it that deliver value to environmental justice communities. Does that help answer the question, or can I be more specific with certain aspects?
So Oriana was having difficulties coming off mute. Okay.
Okay.
Oriana, also, Just quickly, can I add that one of the things that we're specifically looking at is how to quantify customer and societal benefits, and there is work that we're actively doing to look at that. And Andy Iden, who you saw earlier, and Bashir, who will be presenting later, are building a roadmap on what that would look like and kind of what are the critical key benefits that we need to quantify, and then what kind of approaches we could take to like methodologies that we could take to quantify those values. So that's upcoming work that we're going to be doing. Nick?
Hey, thanks, Nahit, and thanks, Angela. I have a series of questions. They're really quick, just clarifying questions, so bear with me if that's okay. On the nice, I'm going to call it the sandwich slide with the various layers. I think it was number 53. I just wanted to clarify there's a that one, thanks. Also there on 64. Does telecommunication layer, does that include a lot of the wireless connectivity that the company is working on as well? Is that a semantic labeling issue, or should I be looking for wireless connectivity somewhere else here?
Yeah, so telecommunication is the broad capability. I would think about everything from fiber optic cables to field area networks, to wide area networks, to home area networks, AMI mesh networks, all of these various technologies that are available to enable telecommunication as a part of the capability.
Okay, thanks, Nahit. The second question was on slide 61, and this is, I recognize an engineer could answer this question in in a 10-minute response, but a simple yes or no would probably suffice for my level of knowledge. Is the hardware, the widgets, if you will, that gets installed in the field for Fuzzer and Voltvar optimization, are those the same widgets, or are they really separate? In other words, one widget's double duty, or are they really different kinds of widgets?
Yeah, there are a few widgets that do double duty and some that are like focused on one, but most of them kind of overlap. Okay,
thanks. Last thing was when you talked about the distribution automation and substation protection and automation topics, should I think of those as being embedded in the grid management systems layer? And I think you probably said that and I just missed it. I just wanted to confirm.
Yeah, I would think about that as sort of a natural extension of the grid management system. So if you think about going back to the analogy, the grid management system is the brain. It needs to be able to sort of control the muscles. The muscles are either at the substation or on the feeder, right? And so those are the two areas where we are actually deploying some sets of controls. And so that's why we've highlighted the feeder and the substation kind of separately there. So yes, it's a part of grid management.
Okay, thanks for clarifying those things for me, Nahit. Appreciate it.
Thank you.
Angela was next.
Yeah, thanks. I just wanted to ask a question about that DOE recommendations for evaluation and how can the stakeholders know which framework PGE will be using to evaluate investments, and what kind of transparency will be around the time when you are actually doing those evaluations?
Yeah, for all the planned investments that we have that are mentioned in the DSP, we tie those back to whether they are foundational or whether they are least cost best fit or cost benefit analysis. As we move forward, both in the DSP and future rate cases and things like that, where we are looking to expand some of these elements, that's where we will have sort of more detailed justification. But that's fundamentally how we think about it. So I think part of the answer is in the DSP, and part of it will be in future DSPs and other dockets.
In the DSP, Angela, we actually have a conversation around cost and benefits that we've added. And we do recommend that this be kind of a broader conversation around how we quantify and look at benefits and what type of methodologies we use for specific use cases. And Nahit and I have talked a lot about this. We don't think every DER is created equal, and then it might mean that there's multiple different perspectives or methodologies we look at for what we're trying to achieve or do. So, is that helpful?
I'm still a little confused, to be honest. Does that mean you're going to follow those DOE recommendations, or?
Yes, we are trying to, as closely as possible, align with them. In cases where we don't align with them, we will kind of talk about why we are not aligning with them. And so that detail of where we are aligning and where we can't align is in the DSP for the planned investments. And for the investments that we know we are going to make, but we haven't planned for yet, it'll be in future iterations.
Yeah, and I think I want to be clear and see that we need a starting point. And he's done a really good job of figuring out how can we start to evaluate these types of investments, because we are, we need to move quickly if we want to meet the goals set forth in HB 2021 and others that came out of this recent legislative policy. But we do think that this is an ongoing conversation. So Angela, we are looking to use the framework today, but we don't think that that is the end all be all. It is a conversation that we need to continue to have and evolve over time.
Okay. You just mentioned something about this being in the planned investment section of the distribution system plan. I have not read all 236 pages. Can you point me to where that is?
Yeah, so if we could scroll back in these slides to the chapter response, I think it is in there. Section 4.7 of the DSP should have a roadmap of planned investments, activities, and tools to achieve the vision. So that will include whether these are foundational investments, and if they are foundational investments, whether they use least cost, best fit approach, and whether they need a cost benefit approach. And we obviously welcome feedback on all of that, right? Like if you feel, hey, this should use a different approach, you can provide your justification as to why that makes sense, and obviously we'll take it under advisement and see what we can do to better justify these investments.
Did that answer your question, Angela? Is that what you were looking for?
Yes, thank you.
Okay, and feel free if you are trying to find something within DSP, just feel free to reach out to us and we can help you or pick up the phone and walk you through our thought process on the report. Other questions? Okay, we're scheduled for a 10-minute break, so let's move to our break and then we'll come back promptly at 10:25. Thank you, Nahit, for your time. Joe, are you on the call?
Yes, I am.
Okay,
Can you hear me?
awesome. Yeah, we'll give people the rest, one more minute, and then we'll get started. I see you dressed up today. You don't have your normal puffy or hoodie on.
Yeah, I took the opportunity to actually put on a shirt. Yeah.
Well, I think that that must mean that the presentation is going to be pretty special.
Yes.
That's the takeaway.
And I have pants on too. Yeah.
Is this you showing resilience of having to wear business attire?
Right. It's there when I need it.
All right, well, let's get started. Thank you for joining us, Joe, and I'll turn it over to you.
Thank you. So good morning. I'm Joe Boyles, and I will be covering the resilience chapter of the DSP. Go ahead and skip to the next slide. As we jump into it, I wanted to do some grounding on resilience. So resilience has been a recently evolving practice among utilities, but also involving emergency management agencies across the country. The focus started like a decade ago with the increasing frequency and intensity of hurricanes in the southeast. But as weather events and other disruptive events started happening in more areas across the country, the practice evolved and grew, and now is kind of front and center in utilities across the country. We've been leaning on NARUC, the National Association of Regulatory Utility Commissioners, I think is what it is, for definitions of what is resilience. So the ability to anticipate, adapt to, withstand, and quickly recover from disruptive events. And also the National Infrastructure Advisory Council for what are some of the core areas of resilience, like robustness, resourcefulness, rapid recovery, and adaptability. And leveraging the learnings from other utilities across the country, as well as other municipalities as they tackle these disruptive events. So go ahead to the next slide. We chose to couch our response to resilience or our writing about resilience in a couple of the requirements in the long-term plan that address customer experience and collaboration with communities. So as I go through the resilience section, I'll try and touch on where we do that. Next slide. So as a outcome of the recent wildfires that happened in the last year, and the significant ice and windstorms that we had as well, we chose to step back and take stock of all of our resilience efforts and make sure that we were aligned internally and in our coordination with external entities. So we established a resilience team to serve that purpose. So we get together on a regular basis and make sure that we basically take inventory of all the resilience activities that are going on across the company and make sure that we're aligned and we're leveraging each other's efforts and learning. Next slide. Quick overview of the resilience chapter. So there are basically three areas of focus, and I think these are pretty logical. One is customer infrastructure resilience. And we talk a lot in the DSP about solutions that are closer to the customer. And what that means is, in some cases, that's a solution that is in the customer's control. So maybe it's behind the meter storage, but also things that are close to their home. So maybe a community resource center and other community-based response efforts that help with resilience. PG infrastructure resilience, there's a lot that Nahit just covered in grid modernization that contributes to resilience, like sensing and measurement, telecoms, and central management of our grid. And there's also the hardening of the grid itself. Let's use more undergrounding. Like, let's put lines underground where it makes sense, so that they're not subject to falling or burning trees. Operational resilience talks about how we perform as a company. So it's people and process, and making sure that we're basically we have the right people involved doing the right things at the right time. Next slide. So getting into each of these areas a little further, I mentioned community resource centers. So in association with public safety power shutoffs that are performed in basically extreme circumstances under wildfire conditions, we can set up a community resource center that basically serves as a point for people affected by that outage to get information, stay connected, get some critical supplies, and be safe, right? Our residential battery pilot is geared towards behind the meter storage, as I mentioned. So, enabling customers to ride through an event, to be able to mitigate the impact of an outage by using their home battery to power their essential energy needs. And microgrids, I think Nahit touched on this a little bit, but effectively, isolating a section of the grid so that it can maintain its own power for a period of time during a disruptive event. So these are things that we would consider, solutions that are closer to the customer. Next slide. In the infrastructure category, we have basically 4 types of activities that we're focused on. And I've included some of the specific initiatives that are associated with each. And all of these are in various forms of planning. As I noted, the focus on resilience is evolving and relatively new. So, we're evolving our own ability to characterize and develop investment plans for those activities. So things like wildfire risk assessment and modeling, and telecom resilience, right? So making sure that we can maintain communication during a disruptive event. Event learnings, like the ice storm that we just had, an outage that affected 740,000 of our customers. The event in Texas, which I think was pretty prominent in the news, heat waves, and other events that have happened across the country. Other resilience improvements that affect specific customers, like hospitals, police and fire stations. We're looking at specific resilience solutions for those critical customers to make sure that they're available to respond when people need them. And I think we can jump to the operational initiatives. Again, different categories of focus within the operational initiatives. So things that we're planning are just comprehensive outage management planning and preparation, and a lot of that is based on our learnings from the recent the ice storm. It affected such a broad swath of PG's service territory that it basically forced once in a career type activities within the company, things that we had anticipated and planned for, but having to actually put those things into action, presented its own challenges. So we're able to take learnings from that and basically fortify our own ability to respond to those events. It also emphasized our ability to engage with communities to make sure that we are in tight coordination with emergency management agencies, and we understand what different communities need in the event of disruptive outages. So that was a great takeaway from the ice storms. Having tools and equipment on hand, basic things, tablets that are, beyond our basic, workstation in our workplace. Like, we need to be mobile, and we need to be ready. Playbooks that really outline a lot of this stuff. So how do we take a lot of our plans that we have and have been using for decades to respond to disruptive events? How do we make them more accessible, right, and easier to put into action? Supply chain operations, making sure that we have critical partnerships in place so that when we need additional supplies, additional people, additional materials, we have the strategic partnerships in place to have access to those things. And critical materials, do we have enough of, this particular clamp or bolt or wire size, right? So making sure that we're ready with those materials when we need them. Next slide. So we talked about this in the context of customer experience through sort of internal brainstorming and talking to customers. We effectively developed a customer experience vision statement that speaks to resilience, right? Like, what do we want our customers to say about PGE when it comes to resilience? And fundamentally, it's, I believe in PGE, right? That we are a partner, we are there, and they trust that we'll be able to deliver that reliable and resilient service. Next slide. So, key takeaways, and this comes through in the DSP in a few different chapters, but shifts in the climate, but also a shift towards electrification. Like, as we decarbonize, we become more and more dependent on electrified things. And because we are more dependent on electrified things and more of our essential needs are served through electricity, that obviously raises the importance of resilience, right, and the ability to recover from disruptive events. We believe, and I think we've experienced, that the PUC and stakeholders want to know what we're doing. Like, how are you, PGE, working to achieve resilience and deliver that reliable service, right? So, in describing some of the activities that are planned in the DSP, the intent is to basically communicate that. So I think as you go through the DSP and review Chapter 5, I think the question from us is, does this answer that question? Does this help you understand what we're doing? And as sort of a new area of focus, resilience doesn't have a lot of metrics like reliability. So for reliability, we have kind of a required level of performance across the grid, and those are measured in SAIDI and SAIFI and other similar metrics. And we're working with other utilities and this community of interest in the resilient space to develop similar metrics for resilience so that we can basically measure our progress over time. And I think that covers the resilience chapter. So any questions?
Nick, do you have your hand up? Would you like to go?
Hi, Angela. Hi, Joe. Thanks. I have to confess, I had a couple of things going on at home, so I was in and out during this presentation. Joe, I apologize For that, I wanted to just ask a question which you might have answered and I missed. It might be the case also that this is a whole other side conversation, and so please be upfront about that. I don't want to take any more time than is necessary today. Recognizing that the PUC will have some role in this too, and this is probably not entirely PGE's question and answer, when you really step back at a high level, does the plan in the long-term plan section, long-term vision section, currently distinguish between like hardening or resilience investments and other investments? I mean, are they labeled as such, or are there investments that provide multiple benefits and they're labeled in that respect, or is it characterized in some different way? Again, sorry if I missed this during the discussion. I apologize.
No, that's a fair question. You know, there have been there are investments that are like resilience specific. You know, when we went through a period of like hardening investments that were in response to like earthquake preparedness, that were kind of easy to tag as resilience. I would say those are the exception though, and they were pretty big. Most of the investments, like if you look at the grid modernization kind of investment plan, there's significant overlap there with resilience. A lot of those are reliability and modernization, but they're also resilience, right? So I think it's, you know, resilience is one of the benefits that is derived from a lot of those investments. And there's, you know, reliability in general overlaps significantly with resilience, right? So when we look at, you know, where we're having outage challenges, it's easy to justify like introducing tree wire, right, as an example. So a wire that is thicker and, you know, coated in a protective casing that prevents it from faulting when a tree branch touches it, right? That's tree wire. So I think the short answer is no, it's not that clear, and partly because there aren't the specific measures and cost benefit framework for resilience investments. And that's some of the work that's being done now, right? Is like, it's clear that we need to make sure that critical infrastructure like hospitals maintain service during a significant or disruptive event. How do we justify that investment? It makes sense. Like, I think everybody thinks it makes sense, but it may not pass the cost effectiveness test that we've traditionally used for utility investments, right? So I think working with the broader stakeholder community to achieve that clarity is important. And it's interesting, I think, in the context of the resilience work, to engage that community, right? So there are other, like you said, you know, the PUC has a role, but there are other Oregon departments that also have significant roles in resilience, like DHS, and you know, the Department of Transportation. Like these have all come up in the context of the resilience conversation, and who owns what slice, like who is actually going to deliver resilience solutions in a specific area. So I think we all have a role to play, right? And it's good that we're now working more together on those solutions.
Thanks, Joe. Appreciate it.
Yep.
Other questions? All right, Joe, thank you for your time. I appreciate it. And we'll move on to the next portion of our presentation. Is Misty on the call today?
Misty is, but we're tag teaming this, so I'm going to start, and then I'm going to hand it off to Misty to cover a portion. So you're stuck with me for a little bit longer.
Okay.
Nahit teed up plug and play as one of our strategic initiatives in the context of delivering on PGE's goals. he described it well, right? Which was, you know, to be able to plug and play. I think, you know, internally we're thinking about, you know, people should think about their new DER as like an iPhone, something that is pretty simple to take out of the box and use. So conceptually, that's what we're aiming for DER integration, right? Is we want it to be easy. So we need to be able to communicate, you know, what devices should go where and when. I don't know that I can describe it more simply than that. We don't want it to be burdened with a bunch of technical requirements and jargon. We want it to be, you know, sort of easily accessible. It being the ability to integrate a DER for customers in any walk of life, right? So hosting capacity is a big step in that direction. It is one of the capabilities, being able to perform hosting capacity analysis, being able to say, this is how much capacity is available at a point on the grid to plug something in, is critical to that plug and play capability. So in the plug and play chapter, it is largely focused on that sort of that DER enablement through hosting capacity analysis. What we have here on this slide is basically a clip from the DSP requirements. And what it represents is just an increase in the granularity of hosting capacity analysis over time. And that granularity is both in detail, so the amount of data that we're, you know, providing in our hosting capacity analysis, and frequency. We agree with that progression. So you know, as we go through this chapter, we'll talk a little bit about what that progression looks like from our perspective. I think we can go to the next slide. So this basically reiterates what I just said, which is, you know, mature hosting capacity analysis is essential to this plug and play future, and it'll provide visibility for us to be able to communicate these things to customers for a variety of DER integrations. Next slide. Quick overview. So the plug and play chapter basically talks about our current hosting capacity analysis capability. And fortunately, over the course of producing this iteration of the DSP, we've been able to bring a lot of people along through the technical working group to talk about our current distributed generation evaluation map. So that is just kind of an enhanced version of our net metering map that was already available on the website. Hopefully, most of you received an email from us at the end of September that talked about the availability of the map. And I think Shadia just dropped a link to it in the chat. So if anybody didn't get that email, it was a Friday afternoon. The link is here in the chat for anybody to access the map. We talk about basically the maturity model of hosting capacity. So what does it mean to go from you know, the granularity we have today, which is this pretty rough sketch of availability of capacity on the grid, sort of in broad brushstroke terms, right? We can say this feeder is ready, but we have a challenge right now saying, well, how much? Like, how much capacity can it support? And, you know, from that point down to, you know, we know that this feeder has this much capacity at this time of day, and will deliver this much value to a customer, right? So that's a highly mature hosting capacity analysis. So the chapter covers that progression. We go through the options analysis for hosting capacity as outlined by the DSP requirements. So What does it mean to do it at a granularity of a feeder on a yearly basis? What does it mean to do it at a section level on a monthly basis? And what does it mean to do it at a section level on an hourly basis, right? So the different options. So basically walk through the analysis of those options, what each one would cost, and then following that, we basically provide our recommendation and our plan of how we're going to proceed with hosting capacity analysis. Next slide. This is our depiction of that roadmap. So I'll start at the bottom. So the bottom basically represents the targeted use cases. So what we think you can do with the hosting capacity analysis that's provided at these different points in time, right? So what can you do with hosting capacity now? Basically identify favorable DER locations, but really specific to distributed generation. So the first iteration of our hosting capacity map focuses on distributed generation, and that is to say, it's not going to tell you where you can put an electric vehicle charger. It's going to tell you what is maybe a good location for a rooftop solar installation. As we progress through hosting capacity analysis, we're able to incorporate that into our decision making. So if we have a DER forecast that says we expect high penetration of solar or EVs in a particular area of our grid, we could also look at our hosting capacity analysis and say, what is the grid's readiness to accept that level of DER integration? And then we can basically propose investments for that area of the grid. And then at the far end, basically using our knowledge of hosting capacity analysis to promote DER integration. So maybe being proactive and saying, this is the best place to go. Like this place is ready, kind of getting to that plug and play future. So next slide. Quick snapshot of the distributed generation evaluation map. So this is where we are today. In the kind of maturity model that we provided in the DSP, this is stage 1 of maturity, which is using what we call a distribution system characteristics to communicate a level of distributed generation readiness. So in this case, what you see on the map are distributed generation ready, that's DG ready, feeders. So feeders that are ready to accept distributed generation because they have the protection equipment necessary to make that integration safe. It won't disrupt reliability. It won't create maybe unsafe conditions for customer equipment or PGE infrastructure. So those are the areas that are ready to accept distributed generation. I think we can go to the next slide. So this is, we're getting into the options analysis, and I'm going to hand this off to Misty so she can describe basically how we went through the options analysis, how we developed the evaluation criteria, how we applied those to each of the options, and then what the result was for that options analysis. So Misty, if you are ready to take the mic, the floor is yours.
Yes. Good morning, everyone. My name is Misty Gao. I am a strategy and planning analyst on distributed resource planning team at PGE. In the next few minutes, I will introduce PGE's evaluations on hosting capacity option analysis and how PGE creates its hosting capacity execution plan based on these evaluations. This slide here shows 3 option analyses outlined in the OPUC 2005 DSP requirements. They represent increasing degrees of granularity from option 1 to option 3 in both time and data resolution. The Apple Drive modeling can support the analysis in all 3 options. So you can see here, option 1 represents a base case and a starting point for performing hosting capacity analysis and requires annual analysis on minimum daily load at a circuit level. And option 2 requires monthly refresh on minimum daily load at a feeder level. So moving from the annual to monthly hosting capacity analysis updates will require automation of different components of the process, and as well as completing the field verifications and underlying data updates. The automation will allow more frequent updates and improve the accuracy of the information. And option 3 requires hourly assessment at the line segment. Performing hosting capacity analysis on an hourly basis at the line segment creates an exponential increase in the data collection needed, which requires expanded storage and processing capabilities, and increase in monitoring and the data query process. So in many cases, new equipment will need to be deployed, and existing equipment may need to be reconfigured. Next slide, please. In the evaluation analysis of each option, PGE considered these questions from the DSP guidelines. What are the cost and timeline? What are the implementation barriers? How frequently should the data and map be updated? And how helpful will this be for grid needs identification? And how helpful will this be for interconnection studies? These questions will translate into evaluation parameters shown in this table. We estimate the timeline for option 1 is about 12 months and cost around $141,000 for model setup, planning data minimum load and peak load, drive analysis, GIS display, reporting, etc. The timeline for option 2 is around 24 months, and the cost for option 2 is about 12 times the cost of option 1. Since option 2 requires monthly refresh instead of annual analysis, extra cost is needed in such as IT, server, and equipment. And a significant increase in timeline and the cost is to be expected for option 3, which are estimated at 24 to 36 months and $58 million separately. So the outcome of this evaluation of analysis may not be precise with respect to the actual cost of executing the different options, but we expect that it is a representative of the relative complexity, effort, and cost among the 3 options. The detailed breakdown of cost and the description of the evaluation parameters for each option, such as data security risk, implementation concerns, interconnection use cases, implications, etc., could be found in the DSP document, Chapter 6. So after the evaluation analysis, PGE chose to have a hosting capacity execution plan by using an approach between the option 1 and option 2. Next slide, please. PGE plans to perform hosting capacity analysis twice annually at the feeder level starting late 2022. So there are several factors that make us to take this approach. First, PGE currently is required to update data minimum load analysis and limited generation feeder list twice annually. Data minimum load is a primary input in conducting hosting capacity analysis. And the second, PGE is also required to update its peak load data twice annually. This is also an input for EpiDrive model to run hosting capacity analysis scenarios. And third, PGE uses feeders as the unit of infrastructure. Also, PGE's approach to hosting capacity analysis has been shaped by conversations with stakeholders and the best practice we gathered from the other utilities that have implemented the hosting capacity analysis tools and the methodologies. We conducted a series of feedback sessions with our technical working group and interviews with peer utilities to gain the insight into the lessons learned and the most effective approach to deliver the value to our customers. So the cost of conducting hosting capacity analysis twice annually, roughly 2 times the cost as described in the option 1. So this slide here compares our current practice with our proposed approach. Our current practice uses available data and does not incorporate to use of the Drive tool. PGE currently owns the tools to perform hosting capacity analysis using SIME and Drive models system-wide. So the process to do so add a little more labor than the current method. In order to transition from the publishing data minimum load twice annually to produce a hosting capacity analysis twice annually, we will need to invest additional around $200,000. Next slide, please. And this slide categorizes the activities, resources, and effort needed for the PGE's hosting capacity execution plan. PGE's distribution planning team will conduct the main analytical work, and our GIS team will utilize the data outputs from the EpiDrive tool to publish the system maps. And our interconnection team will assist in report verification and posting the information on OSIS. So the whole process look like this. Our engineers will first create, validate, test the functionality of SIME-based model for all the 653 feeders in PGE territory. And PGE use automated scripts and works directly with SIME to correct errors in the models. And once these models are created, and quality assurance and accuracy assessment will be performed. And the work will be done to create peak and data minimum loading conditions from the historical SCADA loading data. And then SIME models will be created with the peak loading and data minimum loading conditions. Output data from these SIME models are validated and loaded into Drive. And the Drive runs automated scripts and selects the necessary feeder and the system data from SIME. So, and then the analysis is performed in Drive, one feeder at a time, and the results will be valid again, and the heat map will be consolidated, and Excel files will be prepared for publication. Next slide, please. This is a sample screenshot of a hosting capacity heat map, which is an outcome from our Drive model test running for hosting capacity analysis. The result provided hosting capacity at line segment level. So it is possible that PGE's initial hosting capacity analysis will provide results at this level. And we will investigate the possibilities and how to transition it to a public-facing and GIS platform. The initial hosting capacity execution plan outlined in the slides here put PGE on a path to move from stage 1 objective in DSP guidelines. It is a provide a plan to conduct hosting capacity evaluations in the near term to stage 2 objective, conduct hosting capacity analysis, inform stakeholders of potential interconnection challenges. This plan also enables us to take advantage of data and tools that are already established, reduce the roadblocks for us to executing the initial hosting capacity analysis. We look forward to completing this analysis and initiating additional rounds of stakeholder feedbacks to advance understanding what is most valuable and focus efforts in future iterations of hosting capacity analysis. And next, I think Joe will cover the chapter takeaways and key points of the whole chapter.
Sure, thanks, Misty. So as I noted, Shadia put the link to the distributed generation evaluation map in the chat. So we are excited to hear your feedback. You know, we got a lot of great feedback from the technical working group as we worked through the various iterations of the drafts for the map. And now that it is available to all of you, we're interested in hearing what you have to say. And I think from our perspective, we want to know that it adds value. Like, so is there a way you can use the map to facilitate analysis that you want to perform or a decision that you want to make? As Misty noted, currently we are already required to do the daytime minimum load analysis and generation limited feeder analysis twice a year. So we're able to leverage that effort, take the outputs, put them in the drive tool, and use that to execute hosting capacity analysis. So I guess I'd characterize that as we're already halfway there to conducting a hosting capacity analysis in terms of having the inputs required. So now, you know, we're going to use those inputs to execute hosting capacity analysis on that cadence, right, which is twice a year. So we'll start doing the analysis, I think, as Angela mentioned earlier, in Q1, Q2, with the hopeful outcome of being able to publish something around this time next year. You know, with respect to the evolution of hosting capacity analysis, what we glean from our conversations with other utilities that are a little further along on this journey is that it like, we don't want to maybe step back and think about what you saw in that option 3. So option 3, conducting hosting capacity analysis for an hourly level of granularity across the system. It costs a lot of money to do that. We are making a lot of those investments already, and we noted that in the DSP. So maybe half of that cost is sunk in investments in things like the distribution management system and automation and sensing that devices that we're deploying across the grid for other grid modernization benefits. But we probably don't need to do it for the whole system all the time. Right. So I think what we're looking to do is develop a targeted approach that says we need to update these feeders at the right time so that we have a hosting capacity analysis result that is available to partners that makes sense at the time they want to use it. So that's going to be our approach, is targeting those updates and those investments in hosting capacity analysis so that we have the right hosting capacity result at the right time. And that doesn't mean doing it real time, all the time, for all the feeders. So we're going to figure out how to target it. And you'll see that recommendation.
Thank you, Joe and Misty. We're at time, but we do have a couple of minutes for questions. Do people have questions? It looks like we have a question from Stephen and then Nick.
Hi guys, can you see me?
Yep.
So I just posted my question as well to the chat just to make a record, but reviewing the DSP, which I thought was laid out pretty well, curious to learn where does the content highlighting the mechanisms being considered by PG&E for planning for the demand side load resources integration. So it's heavily weighted to supply side and generational stuff, but it has nothing to do with behind the meter asset integration. And I fear that you guys are missing half of the opportunity for demand side planning. So that type of thing, where is the content in this filing?
Oh, Joe, do you want?
So I believe, so in the DSP, I think we make that, we add that caveat, which is this iteration of the DSP is focused on distributed generation. So, so I'd say good that you found that omission because it was deliberate, right? There is no discussion of integration of demand side resources yet, right? So I think in future iterations of the DSP, we're going to expand the reach of hosting capacity to incorporate demand side resources.
Okay. And what is that the only mechanism is hosting capacity, or are you guys actually looking at like market and looking at regulatory reforms to allow you to have the opportunity to adopt behind the meter stuff in your planning process? Because right now that's outside. Remember workshop number 2, you kind of gave like a boundary of what DSP looks like. And so right now I don't see any information in the filing that talks about what reforms need to happen to help, like Nick pointed out last question, the regulatory process to give you the access to start to incorporate these other kind of approaches to the distribution system operation, not planning.
So part 2 of the DSP will encompass our locational DER forecast that Andy's working on. We touch on behind the meter assets throughout the report. So there is some language in the baseline section or chapter 2, our vision. There's also discussion about that in our evolved regulatory chapter and the things that need, we believe need to be addressed in kind of the near term. And then we have some of that language. Do we have it in the grid mod section too, Andy? You're probably closest to that work.
Yeah, I think it's sprinkled throughout there, but I would say just my point was going to be, I think Joe's comment is not that the DSP it only considers distributed generation, but just that the hosting capacity analysis here, because like Angela mentioned, we do include in the baseline section, obviously the integrated DERs today that I showed. This is a function, I think, of the breaking the first filing into 2, where we didn't want to overload the first filing with the full locational DER forecast, which would include things like flexible loads and energy efficiency and things like that behind the meter, which will be in part 2, August of 2022. So I think, Stephen, that's probably where more of the discussion. We certainly intend to elaborate on, we didn't want to overburden that, but we do talk about our method of forecasting adoption of flexible loads and distributed generation as well. And energy efficiency is currently, that's handled by Energy Trust, and it feeds into our IRP. I think in part 2 of this filing, we'll have a lot more room to discuss locational energy efficiency impacts on both the load forecasting efforts and solutions that we identify on the grid.
Okay. So interest of time, let's move on to Nick's question.
Thanks, guys.
Thank you, Stephen.
Hey, thanks, Angela. Thanks, Misty, and thanks, Joe. I just had a really quick question. I think on slide 87, I appreciate you to kind of taking that nuance in the comparison approach of what's already required as to simply, just what are the additional costs. And my question is, of that $195,000 incremental cost, is any of that, would any of that be one-time setup kinds of costs, or would those be biennial, if you will, kind of on an ongoing basis?
These are all basically ongoing costs.
Okay.
Yeah.
Okay, thank you.
Yeah.
Okay, thank you, Misty and Joe. I appreciate your time. And we'll move on to Chapter 7, our regulatory framework. Nihi?
I'm sorry, can I ask a question before we move on? I apologize.
Yeah, sure.
So this is Angela from OSIA, and I just opened up the map. Thank you for putting the link in the chat. Will there be time at some point to go over that map? Is there another session planned, or are we in the stage of just emailing questions in about the new map?
I think on our DSP website, we have a map user guide there. So if you go to our website, probably you could just read the user guide first. And if you have any questions, just give us an email and we'll help you to navigate the map.
I'm sorry, I wasn't clear. I don't have questions about navigating the map. I have more bigger questions about the map and what it's supposed to show and what it does show. Is there going to be a space to talk about that?
Yeah, so we did host a series of workshops to get input. I think Misty and Joe collected about 100 feedback. Angela, were you invited to that process?
Yeah, I was part of all of those. So this map now is very different. It has some good improvements, but it raises new questions.
Okay, yeah, we're working to continue to evolve the map. So we can sit down with you and have a, kind of walk you through what we are thinking of enhancing it and get your feedback on the current map. And so, Misty, could you reach out and coordinate that with Angela?
Yeah, sure.
We don't have anything formally scheduled yet, Angela.
Okay, thanks. That'd be great. I'd appreciate that.
And thank you, Misty, for being willing to do that. I appreciate it. Okay. Evolved regulatory framework, Nihi.
Thank you, Angela. Hello again, everyone. For those who might have just joined, I am Nihit Shah. I am a senior analyst, senior strategy and planning analyst on the distributed resource planning, and I will be talking us through Chapter 7. So moving to the next slide, as we have done with the previous chapters, let's talk about how we have laid out the chapter. As we talked about in the vision chapter, that there was a sort of the second or third session earlier today. We do believe that policy and regulation has a very important role in enabling the vision and achieving the goals that we have sort of laid out. So in this chapter, what we've done is we've laid out the policy landscape at a high level, talking about the high level drivers for why there needs to be some changes. And then we talk about sort of the regulations that lie between the policy drivers and the actions that utilities and partners take. And so we've sort of used Section 7.4 to identify what are the key opportunities that are available and what barriers exist in advancing our vision. And so we will talk about those regulatory elements in the following slides. And with that, we can move to the next slide. So the way we've thought about this is in sort of three categories. The first is a set of new regulations that basically accelerate DER adoption and PGE's ability to leverage the value that those DERs provide. In addition to the new regulation, we need to make sure that all current regulation is aligned so that we aren't having a conflicting kind of direction in how we are trying to optimize the grid. And lastly, we have ongoing discussions in regulations that are being updated, and we believe that those are important to mention, and we talk about their relationship with the DSP. I do want to mention that this is kind of our first take on the regulatory elements, and this area is definitely ripe for discussion and ripe for evolution, and we do expect to see that as we go through subsequent rounds of the DSP. Next slide, please. So talking about the elements that we mentioned in the DSP, we're going to just go through the list here and talk about them briefly, and then if you have any questions, we can kind of get back to them. The first one we talk about is DER resource cost effectiveness. What we mean by this is the ability to value the DER across utility values, societal values, and host customer values. Our approach here is to develop a new tool, and we want that tool to be aligned with the National Standard Practice Manual as much as possible, accounting for jurisdiction, our jurisdiction specific implications on some of those pieces. And so we are in the process of developing the tool, and hopefully we should have something available such that the non-wire solutions that are a part of DSP Part 2 will go through that cost effectiveness screen. And that cost effectiveness screen will also act as one of the elements in how we evaluate the modernized grid investments. The second piece that we want to talk about is aligning utility incentives to scale DER programs. Today, the way we treat utility incentives across supply side resources and distributed energy resources is not the same. And we would like to pursue the conversation of trying to align regulatory mechanisms to have the utility treat DERs the same way it would any supply side resources from an incentive standpoint. And so that's something that we think is important and has been raised previously, and we feel like that needs to be a part of the continued discussion here. The third element that we talked about, that we've talked about in the DSP, is regulation impacting interconnection of DERs. This is rather a category of regulations rather than a single regulation, or everything ranging from the work that is outlined in UM 2111, including smart inverter standards, getting ready for FERC 2222 if and when that may happen from our perspective, and understanding how changes in cost allocation and cost sharing principles can take place in order to encourage interconnection across the board. The next slide talks about a few other elements. And so basically, we want to also highlight the fact that there needs to be some regulation on the EV side to make sure there is alignment across how cost sharing happens between light, medium, and heavy duty vehicles. Today, we have done some work on ensuring that medium and heavy duty vehicle adoption is not encumbered by the process through which they connect to the grid. But a similar process is not necessarily set up for light duty vehicles. So in that, the marginal customer that may trigger a distribution system upgrade for a light duty vehicle will be disincentivized from adopting it. And that is a piece of regulation that we think could be improved in a way to help sort of foster our decarbonization targets. The next piece that we want to talk about is the comparable treatment of non-wire solutions to traditional T&D solutions. So similar to how we need to make sure DERs are treated akin to supply side resources, we need to make sure non-wire solutions are treated akin to traditional T&D solutions. And what I mean by that is that traditional T&D solutions have a certain approval process and a certain cost recovery process, and functionally, non-wire solutions are just another tool in the tool belt of distribution engineers, and it should be treated as such. And we should have clear guidance on how non-wires and traditional T&D solutions can be aligned and can be streamlined so that one solution doesn't, the regulatory process of one solution doesn't become the reason for its for us not adopting it. The penultimate one that we want to talk about is the regulatory guidance over enabling inverter-based DER generation. So what we are talking about here is that we currently go through the process of interconnection to identify, hey, this is a substation, and it's, this marginal PV system is going to cause a substation upgrade. But Alternatively, if we have forecasts that show that there is likely going to be adoption of solar in that area and that old substation needs to be upgraded, there needs to be regulation around how PGE can proactively try to upgrade that substation as a way to encourage the inverter-based DERs, such as batteries and PV systems. And so this kind of guidance isn't necessarily available, is not necessarily as robustly available today. And we feel like that is something that can be discussed a little more. And lastly, streamlining regulatory dockets. This, I think, has been highlighted both in UM 2005 order, the final order that issued the DSP, in that we see there are several elements, data elements in the DSP that overlap with other reports and plans, from the smart grid report to transportation electrification, net metering, qualifying facilities, reliability reports, and the like. And while we understand that we need to make sure that this information is available to stakeholders, there might be a way to streamline them so that this information can be available and can be used by stakeholders without necessarily needing as many reports and plans as there are today. And so that streamlining, I think, is a conversation that we all must have. And hopefully we can come to a conclusion where we can present data in certain formats that mitigate the amount of work on the utility in a way for us to focus on the activities that add direct value to customers. With that, we can move to the next slide. And I kind of want to wrap up the slide. We are raising awareness fundamentally on our cost effectiveness work. We are raising awareness for how we would, how others are performing alignment between DER offerings and supply side offerings in other jurisdictions. We are also raising awareness for how others are aligning non-wire solutions and traditional T&D solutions. And we look forward to the discussion about interconnection of DERs in UM 2111. On the other hand, we are calling for action in broader discussions within the docket UM 2005 and other places where the distribution system is impacted, where we can talk about aligning EV regulation around light, medium, and heavy duty vehicles in terms of a cost sharing principles, proactively enabling inverter-based systems as a way to remove barriers to those DERs, and integrating different dockets to drive operational efficiency within the utility as a way to focus more of the utility's efforts on direct value add activities. With that, I'm happy to take any questions.
Hey, Naheed, did I skip one of your slides?
I do not believe so.
Okay, so because you had two that looked exactly the same, so I don't know if you.
Oh yeah, no, that was right.
Okay, good. If I moved on too quickly, thank you for presenting. It doesn't look like we have any questions in the chat. Do others have questions in the audience? Okay, well, Naheed, thank you for your time. We appreciate this is your third presentation, and we'll let you off the hook now.
Thank you so much. Thank you all, everyone.
Next, we have Bashir. Bashir, are you on the call?
Yes, hi.
Hi, good morning.
Hi, everyone. My name is Bashir Salpagarov. I am another analyst, strategy and planning analyst from DRP team. We are running a one department show today, so everybody's from DRP. I'm gonna be talking today about our plan for development of part 2. And as we are moving to the next slide, I wanted to mention why we're doing this. Plan for development of part 2 is part of the language that we had in UM as a requirement, and it wanted us to prepare for upcoming transition period and include high-level summary to discuss following items. First is how legacy distribution planning practices will be transitioned to the requirements of Part 2. Second is whether all legacy distribution planning practices will be transitioned in time for filing Part 2, and if not, the expected time frame for the eventual transition. And the third is efforts to synchronize IRP activities with the requirements of Part 2. With that, let's move on to the next slide. And in this slide, I'm going to point out 3 main areas that we're working on to meet these requirements. And it was mentioned a couple of times during the presentation by Nikhil, and it was touched by Andy as well, because this area does kind of intersect with other requirements and other chapters of our document. And this is our improved forecasting solutions. We are working on improving our capabilities to do a broader analysis. And I'm going to touch on this a little bit, expand on this on my following slides. The second area I'm going to be talking about is going to be how we are exploring NWS as an alternative to traditional option. And the third area to talk about is what are we doing to align our work with IRP as part of our broader goals and improvements and DSP efforts as well. Let's move on to the next slide, where I'm going to be expanding a little bit more about our load forecasting tool. So we are continuously working on advancing our DER modeling tools, this time by contracting with consultants to build an in-house bottom-up adoption model applied to behind-the-meter DERs and electrification. This model is called, this tool is called Adopt DER. The Adopt DER is also a model that improves on prior forecasting techniques because it increases transparency of the modeling approach. It increases inputs, outputs, algorithms, captures broad resources, resource parameters, and key assumption. The model ties to ETO forecast where possible and leverages open source best practices, including but not limited to Caltrack, NREL, PVWatts, ReUp-Lite, EVI ProLite, and end-use load research studies. This project is broken down into 2 phases. And phase 1 focuses on providing the system-level impacts of DER adoption for integration with PGE's upcoming IRP. Phase 1 development of Adopt DER was completed in Q2 of 2021, with the final draft result shared in one of our DSP meetings, and the final system-level results shared in IRP monthly roundtable in August of 2021. Phase 2 of Adopt DER model provides the locational results of DER adoption to be translated into localized impacts of DERs. Phase 2 basically is planned to be finished in Q2 of 2021, and that is our initial plan. It may take a little longer. We're not sure yet, but it will be aligned with the DSP Part 2 requirements. Phase 2 also represents a key step in both providing critical data to accelerate DER adoption and enable key studies to understand the transmission and distribution impact of DER adoption on both load and hosting capacity. PGE also expects to use these capabilities for non-wire solutions where possible. With that, let's move on to the next slide, where I'm going to be talking about our non-wire solutions. Non-wire solutions has been around for a while, but it has never been. We have always had some type of non-wire solutions, but it has never been looked into it as in the depth where it could be competitive with our traditional solution. So with the non-wire solutions, PG will be exploring how non-wire solutions can replace, defer, or be combined with traditional T&D solutions. PGE supports partner and regulator interests in understanding how NWS can complement environmental justice, and foster procedural equity for historically underrepresented communities, creating a more equitable system. As you may know, in the part 2 of DSP, we have a requirement of including minimum of 2 pilots for NWS. PGE is developing internal process for NWSs and acquiring a tool that will be capable of running more comprehensive analysis. PGE's new process document for NWS is developed with input from relevant departments in the company that are involved in or affected by distribution planning processes and community engagement. Our ultimate goal will be for this process document that we're working on with capabilities in place, analysis capabilities in place, it will be converted to a policy where any investment that we're planning for a distribution system will be equally compared for traditional solution as well as non-wire solution. Let's move on to the next slide, and I'll talk a little bit about our efforts to synchronize with IRP. All of these new tools and new expanded capabilities to do a broader analysis, more comprehensive analysis that are required for like NWS, that are required for as part of our forecasting tools, will enable us to get more granular data on DERs that can be fed to IRP systems and can be included possibly in the next IRP filing that will take place probably in the next couple of years. So kind of all of our work that is being done as part of the part 2 is somewhat going to be a beneficial to synchronize or help us better synchronize with IRP. And with that, let's move on to next slide. And as a key chapter takeaways, I would point out these 3 areas. First, that PGE provides details focusing on planning, practice updates around distributed energy resources, forecasting potential, and non-wire solutions. Details on IRP interaction with the DSP, focusing on the upcoming IRP. Second, due to the operational versatility of DERs, create a dynamic operational environment in which greater levels of data analysis and optimization are needed for the company to continue to maximize value for customers. And third, improving PGE's planning capabilities is a critical step in enabling and leveraging DERs for different use cases, such as non-wire solutions, improved asset utilization, and other projects that provide community benefits. We have done some work already in the past 2 years plus. We are in a process of changing and gaining, like Nikhil mentioned earlier in his slides, Andy mentioned in his slides, Joe, Misty mentioned, all of these new functionality that we're working on is going to help us to prepare better for part 2, meet the requirements, and exceed them. So just to confirm that we are on the way of meeting these requirements, and we are planning to get there as we plan and exceed the requirements as far as we can, wherever we can. With that, I'm ready to take your questions.
Bashir, it looks like we don't have any questions in the chat, so maybe take some on the phone if there's anyone who has questions. All right, Bashir, thank you so much for your time. I appreciate it. We'll move on to the next steps portion of our presentation.
Thank you.
Thank you. So we understand the DSP, the guidelines are in evolution, but our approach to meeting those guidelines are in evolution as well. The report that we will file on Friday is our best attempt to begin the DSP process. We understand that this process will be, we'll probably be filing a DSP every 2 years. And we do hope to continue to gather feedback and refine the report as we move forward. And so we see this as just our first attempt to capture how we envision the distribution system to look, but we don't see it as the place where we end. And so I want to thank everyone in this process who provided feedback, contributed into all of our meetings, and just know that we expect to continue this process, and we look forward to hearing your thoughts on our DSP. We're hoping to get feedback on what did we do that you really liked and you want us to continue to do, and where are the areas where you think that we should improve. All of that, we'll take that feedback and use it to improve in future DSPs. I want to point out for part 2, this first part, we're really focused on transparency, setting up a framework for how we'll engage with communities, setting up a framework for how we'll start to think about the distribution grid and modernizing it. We did discuss some more concrete things like how we'll approach hosting capacity, but I really feel like a lot of the rubber meets the road in part 2. Part 2 will be where we actually start to talk about how our DERs impact the distribution system. So today we've kind of talked broadly about how DERs affect the system as a whole, but we will be doing locational forecasting through our grid needs identification. That's where we'll actually start to apply a lot of the principles that we talked about in this part 1. And then we'll start to think about solutions. How do we actually solve the grid, whether that's with non-wire solutions or traditional solutions? We'll be thinking about how we move that process forward. And then lastly, how do we put together a suite of actions to modernize the grid? We do see the second part of the DSP working in parallel with some of our other major filings, like our transportation electrification plan. Most notably, I will say that we will start to forecast and understand the impacts of DERs on the system, but where we see those things get applied, like how do we actually address those, the programs that we offer, it'll be in places like our TE plan, and then for those of you that are familiar with our flex load plan, we'll also be putting together a multi-year plan which will speak to the specific actions of how we will work with customers where, behind the meter, kind of the question, getting to the question that Stephen asked earlier. So we will work in partnership with those teams that develop those specific action plans around the resources, and then we'll try to collaborate that into our action plan and paint a holistic picture so you can see how we're approaching the distribution system. So for the next steps for part 2, we do intend to have monthly meetings. We had a lot of lessons learned from this first part of the DSP. One of the things we learned is writing takes a long time, coordinating internally to get the actual, all of the work we're doing on paper, come up with plans on areas where we need to meet specific guidelines, but we're not necessarily doing those things today. That takes a significant amount of time. So we're hoping that we would spend the rest of this year thinking about how we'll do forecasting at the substation level, focused on what are our current practices for distribution system planning today, and then how do we enhance those to meet the DSP. We will probably schedule either 1 or 2 meetings this year to discuss where we're at with distribution system planning and how that will inform our future grid needs identification and solution identification, and most notably, how do we get to our 2 proposal projects for the non-wire solution. Beginning in January and through May, we'll have a series of monthly meetings as we have. You can see from the schedule here that we are putting together what we think would be draft agenda for those meetings, but expect this to refine over time. We will be very limited in the amount of time that we have to do part 2, as you can see on the schedule. So we're really seeking thoughtful feedback through January through May. Once we get into June, that's when we won't be able to incorporate any feedback on the part 2. So we just want to give heads up to our partners and stakeholders today that engagement in that first half of the year is going to be really critical to inform the DSP part 2. And then anything that feedback that we get from the part 1, we'll try to incorporate as we can, but we will be collecting all feedback, and we will commit to evaluating it, whether it's in the part 2 DSP or for future DSPs. We do plan to work, I just want to point one thing out, we do plan to work through the near-term action plan with stakeholders throughout the process. So we're developing a suite of actions that we would implement into our DSP. So with that, I think we're at the end of our presentation. So I'll just leave you with the important dates that we brought up in the beginning of the DSP. And I want to thank you for all of your participation and time in these meetings. And we look forward to working with you on part 2. All right, well, everyone, enjoy your lunch and have a good evening or good afternoon.